de este grupo con el doctor Lou Baxter, por ahí del año 89, cuando él hizo los primeros estudios con PET y glucosa radioactiva, en donde pues se encontró que los pacientes con TOC tenían un funcionamiento anormal a nivel fisiológico, ¿no?, en el consumo de glucosa, en particular en las zonas de la corteza prefrontal y en particularmente en el caudado, y que esta zona estaba con mayor función. Pero no solo eso, sino creo que uno de los parteaguas que fue en la medicina es que cuando se daba tratamiento farmacológico, esta hiperfunción se reducía, ¿no? Pero también cuando se hacía mediante psicoterapia. En ese entonces toda la parte cognitiva no era tan relevante, era más la terapia conductual, pero fue la primera vez que se demostró mediante neuroimagen la eficacia de la psicoterapia, ¿no? Entonces también fue un parteaguas en ese sentido este estudio, que la psicoterapia te modifica el cerebro, ¿no? Te modifica la fisiología del cerebro, lo mismo que los fármacos, ¿no? Entonces, pues ha sido algo, fue muy relevante estos estudios de neuroimagen. Y aquí les presento un dato de ahora de lo que se está integrando, ¿no?, que es el PET con la resonancia, ¿no? Entonces tenemos datos funcionales con lo que se llama morfometría, que es la medición del grosor cortical, y es un paciente diagnosticado con TOC, que pasó muchos años con TOC, y a los 60 años recibe el diagnóstico de trastorno del espectro autista, ¿no? Y le hicimos el PET con resonancia, ¿no? Desafortunadamente sus estudios hoy día no tenemos esta facilidad, este acceso en las instituciones públicas. Lo hicimos a nivel privado, ¿no? Pero pudimos ver en el análisis funcional, bueno, todas estas áreas, ¿no?, de funcionamiento anormal que en la corteza prefrontal de ambos hemisferios, mucho más del lado izquierdo, que cotejan, ¿no?, con lo que se ha encontrado en muchos de los estudios del trastorno del espectro autista, ¿no? La importancia de hacer estos estudios. Claro, es un estudio costoso, ojalá se lo pudiéramos hacer a nivel de tamizaje a muchos de los pacientes, ¿no? Y la interpretación es un estudio pues que a nivel de mercado anda cerca de los 70,000 pesos, ¿no? Entonces realmente no es así de tamizaje, pero bueno, son herramientas que nos empiezan a dar luz en este sentido. Creo que se atoró la presentación, si me pudieran… gracias. Y bueno, luego ya entrando a la parte genética, tenemos ahora pues tenemos estos abordajes que nos permiten hacer tamizajes amplios del genoma, ¿no? Y entonces podemos detectar muchos genes, ¿no? Y en psiquiatría en particular esto ha sido muy relevante porque cuando comparamos los genotipos de muchas personas que tienen, por ejemplo, un diagnóstico, ¿qué tanto nos podemos separar los casos de los controles, ¿no? Entonces, si tomamos muchos casos y muchos controles y evaluamos cuáles genes están presentes en los casos, si realmente los podemos dividir de los controles, ¿no? Entonces, esto desde el punto de vista académico ha sido muy, muy relevante porque hoy día ya tenemos datos para casi todas las enfermedades mentales, ¿no? Y ahorita les muestro algunos hallazgos interesantes justo en este campo, que ya podemos separar casos de los controles. todavía no como para usarlos como una prueba de laboratorio, ¿no? Esto, como les repito, se hace en grandes poblaciones, ¿no? Pero en grandes poblaciones nos da el poder estadístico de separar con digamos, una certeza todavía no muy alta, ¿no? Pero ya nos permite hacer esta distinción entre las curvas de los casos, de los controles, ¿no? Y eso le llamamos el índice de riesgo poligénico, y bueno, y hay otras vertientes, ¿no?, que nos permiten hacer esta separación. Entonces, haciendo estos análisis del genoma, ¿no?, que creo que se trabó aquí la presentación, ahorita les voy a mostrar un poco los resultados que se hicieron, y fueron datos ahora sí que frescos del año pasado, ¿no? Y sobre todo datos donde participamos, donde participó México, ¿no? En donde pudimos hacer este mapeo, ¿no? Nuevamente, como tienen que ser esfuerzos colaborativos, ¿no? Hubo una gran cantidad de casos para ver si podíamos encontrar que había diferencia entre, por ejemplo, el grupo de genes de los pacientes con TOC y los controles que no tenían TOC, ¿no? Y esta es la que sigue. Y entonces aquí les presento este estudio, salió el año pasado en la revista Nature Genetics, en donde se encontraron 30 genes que distinguen a los pacientes con TOC de los pacientes que no tienen TOC, ¿no? Entonces, incluidos la población mexicana y muchas otras, ¿no? Entonces, este fue el del TOC, ¿no? En la que sigue, si me pueden hacer favor de pasarme la que sigue, y bueno, es un estudio donde participaron también muchas gentes de México. Aquí está el doctor Carlos Cruz, que participó en este estudio, que salió en Nature Medicine, la doctora Lilia Albores, ¿no? Y muchos sitios de América Latina, y que se encontraron una serie de variantes también con genes de diferentes ancestrías en las Américas, ¿no? O en el continente americano, que también distinguían a pacientes con trastornos del espectro autista de los controles, ¿no? O genes específicos de los controles. Aquí uno lo que diría, bueno, ¿cuántos son comunes, ¿no? ¿Cuántos son comunes del TOC y del autismo, ¿no? Y de las señales, sí hay algunas señales compartidas, no son lo que uno pensaría las mismas, digamos, en ambos padecimientos, pero creo que conforme se aumenten las muestras, ¿no? Hoy día estamos haciendo un estudio muy semejante, nada más en América Latina, del trastorno obsesivo compulsivo, que creo que lo vamos a poder empatar. Estamos en vías de análisis, y que creo que va a ser muy interesante empatarlo con estos resultados, ¿no? Si me pueden pasar la que sigue, por favor. Aquí les presento todos los esfuerzos que se están haciendo en América Latina de investigaciones genómicas, ¿no? Esto era, bueno, hasta mediados de este año. Desafortunadamente, con el principal financiamiento de estos estudios pues es el gobierno de los Estados Unidos. Ojalá tuviéramos una contraparte, sí la tenemos, pero la contraparte de financiamiento de los gobiernos nacionales es bastante más reducida, ¿no? Entonces, si se cae la parte del gobierno americano, desafortunadamente muchos de esos estudios vamos pues a lo mejor no a lograr las metas esperadas. Pues bueno, estamos ahí haciendo maromas para tratar de mantener los fondos, ¿no? Si me dan la que sigue, que creo que ya es la última. Incluso, bueno, pues ahora con todas las políticas nos piden que quitemos la palabra latino, que quitemos la palabra fuera de los Estados Unidos, en fin, una serie de cosas, ¿no? Pero bueno, es parte de lo que siempre hay que lidiar con este tipo de cosas. Y si me pasan la última, que es creo que es la de conclusiones, bueno, creo que a lo que vamos con esto es que el trastorno obsesivo compulsivo y los trastornos del espectro autista es dos padecimientos que de alguna manera van de la mano. Es una comorbilidad que tenemos que tomar en cuenta, sobre todo en pacientes adultos, ¿no? Y que hay muchas gentes que llegan a la clínica muchas veces con la idea del TOC, ¿no? Incluso el TOC se ha popularizado muchísimo más en los medios de comunicación y los trastornos del espectro autista pues tienen más relevancia en la infancia que en la vida adulta, ¿no? Como que en la vida adulta se acaban un poco olvidando, pero pensamos que ahí es donde están englobados en muchos de los centros de atención de psiquiatría, psicología, una buena cantidad de los pacientes con los trastornos del espectro autista, y creo que es una buena alerta, ¿no? Tener esta visión pues para tomar en cuenta la comorbilidad de estos padecimientos y poderlos manejar hacia el futuro. Y bueno, con eso termino y voy a dar paso a las presentaciones de la… adelante.
Agradecemos la participación del doctor Necolini. Continuando con el programa, invitamos al escenario a la doctora Xochitl Helga Castro Martínez. Ella es integrante del Laboratorio de Enfermedades Psiquiátricas y Neurodegenerativas del INEGEN. Adelante, doctora Xochitl.
Hola, buenos días. Bienvenidos a todos. Yo les voy a hablar una pequeña parte introductoria de lo que es la genómica del autismo en adultos. Mi nombre es Xochitl Castro y bueno, pues vamos a arrancar. Cuando hablamos de autismo, lo primero que se nos viene a la mente pues es en la infancia, ¿no? Pero en realidad es una entidad que nos acompaña durante todo el ciclo de la vida. Y aquí es donde aparece pues un problema crítico, ¿no? Una gran observación, que es que una gran proporción de adultos no son diagnosticados, nunca son diagnosticados. ¿Por qué? Porque el fenotipo cambia a lo largo del tiempo y porque la base biológica de ello no es completamente entendida aún. A la fecha, el autismo es un trastorno del neurodesarrollo que es definido principalmente por dos componentes principales. Por un lado, tenemos… ¡Ay, no avanza! Perdón. Aquí andábamos. Aquí andamos. Dos dominios principales, ¿sí? Bueno, ya me pasé. Está muy sensible, perdón. La comunicación y la interacción social. Y en el otro lado, o en el otro extremo, tenemos los comportamientos restringidos y repetitivos, que por supuesto es una definición fundamental e importante, pero que no nos abarca para explicar la complejidad de lo que es el espectro. ¿Cómo estamos en números? A nivel global se estima que entre el 1 y el 2% de la población presenta autismo. Sin embargo, como sabemos, estas cifras varían de país en país y en muchos contextos, por supuesto, probablemente están subestimadas, sobre todo si hablamos de autismo. Solamente por señalar, en México el único dato que tenemos a la fecha es del 2016, en donde se reportó una prevalencia de 1 por cada 115 niños en un estado de Guanajuato, y que por supuesto hay un consenso en donde la prevalencia sigue en aumento y en donde hay demasiados países que siguen sin ningún registro de esta entidad. Ahora, ¿dónde están estos pacientes? ¿No? ¿Dónde están estos pacientes que están en esta prevalencia? Pues muchos de ellos son adultos que nunca fueron diagnosticados durante la infancia. Y esto puede explicarse por diversos factores. El primero de ellos es porque nunca fueron diagnosticados en la infancia y la ausencia de la historia del desarrollo pues hace que sea menos evidente en la clínica y que por lo tanto sean caracterizados o diagnosticados. Segundo, el camuflaje social, el cual muchos adultos desarrollan estrategias que los hacen capaces de compensar sus dificultades sociales y eso hace que reduzca la visibilidad de que sean detectados mediante la clínica del autismo. Y por último, la comorbilidad o las comorbilidades, cualquiera que sea ella, sea ansiedad, depresión, TDAH, que son estos rasgos o estos síntomas que pueden enmascarar el propio diagnóstico del autismo. Entonces, el problema no es que no estén, el problema es que no los estamos reconociendo clínicamente. Entonces, aunque el autismo persiste a lo largo de la vida, sus manifestaciones no son estáticas, no son fijas, sino que evolucionan. Y aquí se demuestra un poco aunado con la diapositiva previa. Existen algunos rasgos que permanecen, como las características que ya enuncié: la interacción social, la comunicación, la rigidez, pero también hay otros que cambian, como el camuflaje social, como la adaptación funcional a la sociedad o la presencia de las comorbilidades. En otras palabras, se puede decir que el núcleo del autismo permanece, pero su expresión cambia. Entonces, si el fenotipo cambia, o si hay esta variabilidad clínica, y si existe estos cambios, entonces pues esto nos sugiere algo muy fundamental o muy importante, que probablemente no todos los casos de autismo tienen una misma base biológica. Es decir, que hay un mismo diagnóstico clínico, pero que pueden construirse diferentes arquitecturas biológicas alrededor de ella. Una vez que entendemos que no todos los casos de autismo tienen la misma base biológica, necesitamos entender cómo se organiza esto, de dónde proviene esta variabilidad clínica. Y la forma de entenderlo es a través de la arquitectura genética del autismo. En esta imagen, en un extremo, podemos observar que tenemos variantes raras que son de baja frecuencia. De este lado, las variantes raras de baja frecuencia, pero con un gran efecto, ¿no? Y del otro lado, bueno, por ejemplo, las deleciones, las duplicaciones, las variantes de nuevo. Y del lado derecho, del otro extremo, podemos ver el componente poligénico, ¿no? Que son todas aquellas miles de variantes comunes con un efecto pequeño, pero que es acumulativo. Entonces, lo raro impacta, por supuesto, y lo común suma, y que todo en su conjunto contribuye a un continuo de riesgo genético. Y esto, por supuesto, nos explica la gran variabilidad clínica que vemos dentro del espectro. La evidencia actual, hay muchos datos, hay muchos reportes en realidad del autismo, presenta o nos dice que hay una arquitectura genética compleja. Hasta la fecha se han identificado más de 100 genes asociados con el riesgo de autismo y diversos estudios pues, nos permiten observar que todos estos genes y todas estas variantes están distribuidas a lo largo de todo el cromosoma. Y que por supuesto que es importante toda esta cantidad de genes que vemos asociados con el riesgo, pero más importante para nosotros es que estos genes tienen participación en procesos particulares como lo son la sinapsis, la regulación de la transcripción y el desarrollo neuronal. Entonces, si organizamos todo esto, que les vengo mencionando desde la biología, vemos que la arquitectura genética o el componente genético nos puede definir el tipo de paciente que vamos a observar. ¿A qué me refiero con esto? A que variantes raras, que ya está descrito, que variantes raras de alto impacto, que las tenemos por aquí, de alto impacto, se asocian a un autismo que tiene una mayor necesidad de apoyo y que por lo tanto seguramente tendrá un diagnóstico más temprano, mientras que una carga poligénica, la tenemos por acá, se traduce en fenotipos de menor afectación funcional que nos va a llevar a un diagnóstico tardío. Por lo tanto, entender el perfil genético o las variantes genéticas podrían mejorar el diagnóstico y por supuesto que nos abre una puerta a intervenciones más personalizadas. Por último, esto nos lleva a hacernos una pregunta, al menos desde nuestro espacio. ¿Qué estamos encontrando a nivel genético en pacientes con autismo? ¿Qué variantes genéticas, qué genes, qué rutas, qué redes están participando en esta entidad? Y para ello, pues la doctora Mirna continuará con la presentación. Muchas gracias. Gracias.
Agradecemos a la doctora Castro su presentación. Continuamos con el programa. Presentará ahora la doctora Mirna Edith Morales Marín. La doctora es integrante también del Laboratorio de Enfermedades Psiquiátricas y Neurodegenerativas del MEGEL. Adelante, doctora.
¿Qué tal? Buenos días a todos, bienvenidos. Entonces, yo voy a continuar con la línea del laboratorio del doctor Nicolini y la doctora Castro. Y yo ya me voy a ir directo sobre algunos hallazgos que hemos encontrado en el laboratorio acerca de estas variantes genéticas y qué es lo que estamos haciendo actualmente. La siguiente, por favor. En el laboratorio estamos abordando de una manera multiómica a los trastornos del espectro autista, definido como autismo. Y bueno, tenemos 3 niveles de análisis principalmente que estamos haciendo y pensamos abarcar algunos otros más para entender dicha arquitectura molecular de los trastornos del espectro autista. Y bueno, nuestro gran objetivo acerca del estudio de estos genes que están involucrados o posiblemente están asociados con autismo es la identificación de variantes de riesgo a través del estudio genético en multicapas. ¿A qué me refiero con multicapas? Pues que estamos analizando diferentes tecnologías a diferente nivel, las secuencias y las variantes estructurales a nivel genómico. Siguiente. Entonces, uno de estos niveles es a nivel epigenético, en donde utilizamos microarreglos de metilación. Si recordamos un poquito, la epigenética tiene que ver con todo lo que está afectando la expresión genética, pero sin alterar la secuencia. Esta es una de las capas que les menciono, utilizando una tecnología que se llama microarreglos de metilación. Otra de las capas son la utilización de microarreglos de CGH, en donde podemos ver variantes estructurales más grandes. Ahorita voy a ahondar un poquito más en eso, para detectar variaciones en el número de copias de ciertos genes o de ciertas regiones en cromosomas, los 23 pares de cromosomas que tiene el genoma humano. Y por otro lado, ya a nivel más fino, la secuenciación de exoma para identificar nuevas variantes que puedan estar asociadas con los trastornos del espectro autista. Aquí sí ya es una metodología mucho más fina porque podemos ver a nivel de pares de bases, sobre bases, cambios de bases, inserciones de lesiones pequeñas que puedan asociar estos genes con muchos trastornos. ¿Qué tenemos con respecto a las diferencias en metilación génica? Nada más recordando brevemente que es la adición de grupos metilo en citocinas, es decir, tenemos la secuencia de ADN y vamos a agregar estos grupos químicos a la base de citosina. Entonces, ¿qué va a hacer esto? Pues va a tener una implicación en la expresión génica. Y estos cambios de metilación se han visto asociados a diferentes enfermedades, como son cáncer, enfermedades autoinmunes y enfermedades neurológicas. Entonces, el efecto biológico que tiene esta adición de un grupo metilo es que toda la maquinaria molecular no se puede situar en ciertas regiones génicas y por lo tanto va a impedir la expresión de dichos genes. Bueno, aquí yo les muestro un poco de los resultados que hemos visto en este tipo de análisis y hemos encontrado genes que ya han sido reportados en una base muy importante, que es la base SFARI, y esta base de datos están asociados con TEA y ya tienen un sustento científico bastante amplio y con muchas referencias. Entonces, esto es una base muy importante que los que nos dedicamos al estudio del autismo pues utilizamos para comparar lo que nosotros estamos obteniendo. Entonces, de estos genes obtuvimos 4 sindrómicos, 4 de alta confianza, 16 que son fuertes candidatos a tener alguna implicación con los trastornos del espectro autista y 40 de evidencia sugestiva. Todos ellos ya están reportados en esta base de SFARI. Entonces, con esto sustenta también nuestro trabajo y nosotros también de alguna manera estamos validando que estos resultados, que estos genes sí están asociados a nivel epigenético con los trastornos del espectro autista. Y bueno, todos estos genes no les tengo aquí la lista para no aburrirlos, pero luego les podemos pasar el paper. Y tienen que ver con procesos como son la ruptura aórtica, el nacimiento prematuro, el autismo y desórdenes musculoesqueléticos. Entonces, esto es un hallazgo bastante importante porque estamos reforzando también que lo que nosotros estamos encontrando a nivel de epigenético, a nivel de secuencias metiladas, estos genes ya están en una base de datos bastante confiable. El otro nivel que nosotros estamos analizando es con microarreglos de CGH para poder nosotros ver ya variantes mucho más grandes a nivel de grandes segmentos que van desde 1000 pares de bases hasta 5 megabases. Entonces, se ha visto que estos cambios en estos segmentos, ya sea inserciones o deleciones, pueden afectar la organización de la cromatina y la expresión génica y, por tanto, ya la consecuencia final, pues procesos biológicos. Entonces, y les muestro brevemente cómo está el cromosoma y un ejemplo, ¿no? Que están en esta secuencia ciertas regiones cromosómicas ABCD y cuando falta una copia pues se presenta una deleción o cuando hay una copia extra hay una duplicación. Entonces este es más o menos el esquema como nosotros podemos observar estas variaciones en el número de copia utilizando esta tecnología de microarreglos de hibridación genómica comparativa. Aquí, ¿qué fue lo que encontramos? Que en los pacientes que nosotros estudiamos tenemos 47.1% de duplicaciones, 52.9% de deleciones y esto es muy importante. 5% de estas variaciones resultaron ser benignas, 6% patogénicas, 17% probablemente patogénicas y bueno, 72% tienen significado incierto. Entonces esto es un hallazgo que tenemos regularmente cuando hacemos este tipo de estudios, también aunque les voy a mencionar en la exposición de Exoma, pero no debemos de perder de vista estos datos porque pues, la ciencia como va avanzando a pasos agigantados, después podemos regresar y ver si alguna de nuestras variantes cae en y a lo mejor ya tiene una posible explicación biológica. Entonces, esto es lo que hemos hecho con respecto a las variantes estructurales mucho más grandes que la detección de CNVs. Y bueno, nada más para ejemplificar, les pongo aquí un pequeño esquema en donde estos cuadritos están situados abajo de los 23 pares de cromosomas y representan en cuáles de ellos hemos encontrado deleciones en cuáles de ellos, con el cuadrito azul abajo, duplicaciones, y cuáles ya están validados en esta base de datos que les comento, que es espacio. Entonces, como pueden ver aquí, pues sí son algunos cromosomas que ya están previamente reportadas algunas evidencias, pero los más reportados son en el cromosoma 15, en el cromosoma 17 y en el cromosoma 22, que ahorita voy a explicarles un poquito más, porque estos NBs los hemos encontrado en una frecuencia aproximadamente del 20% de nuestros pacientes. Ponme la siguiente, por favor. Ok, entonces es en esta región que les menciono, 22U11.21, que es recurrente en nuestra muestra que tenemos hasta el momento. Esta región ya ha sido previamente asociada con fenotipos clínicos específicos que tienen que ver con la comunicación social. Esta región, que es bastante grande, contiene alrededor entre 30 y 40 genes que son críticos para el desarrollo neurocognitivo, y bueno, no quiere decir que esta región, si alguien tiene CNVs en este cromosoma, vaya a tener este síndrome, pero sí hay muchos reportes que está asociado con el síndrome de George y un riesgo elevado a presentar autismo. Entonces, estos hallazgos pues sí los debemos de tomar en cuenta y estamos haciendo estudios para poder validar estos resultados, pero sí es de nuestra atención que un alto porcentaje de los pacientes han presentado variaciones estructurales en esta región cromosómica. En la otra capa que les decía, el otro tipo de análisis que estamos haciendo es la secuenciación del exoma. Pues aquí brevemente les muestro que tenemos nuestras secuencias de DNA y aquí tenemos una representación para la codificación de un gen. Entonces, estos exones son los que al final van a juntarse de alguna manera, se van a cortar estas partes que se llaman intrones para poderse traducir en un producto proteico. Entonces, en estas proteínas ya se han asociado con diferentes patologías, con diferentes enfermedades, y entonces lo que nosotros quisimos hacer fue secuenciar las muestras que nosotros tenemos de los trastornos del espectro autista y ver con cuáles secuencias podrían tener alguna de estas variaciones genéticas. Entonces, lo que encontramos aquí fueron, nada más les voy a mencionar rápido, de lesiones 120, inserciones 186 y variaciones del tipo SNP de un solo nucleótido 2715, que es la mayoría que abarca nuestro estudio, y no identificadas 65. Entonces aquí está la gráfica de pastel para que vean también los tipos de variaciones que encontramos, la mayoría que son SNPs. Y por acá tenemos las variaciones que están clasificadas en las bases de datos como benignas, las patogénicas, las no patogénicas y las de significado incierto. Entonces, como pueden ver aquí también, muchas de ellas caen en estas de significado incierto, otras en las benignas, patogénicas y probablemente patogénicas. Y también ya hemos validado algunas de ellas que están en la base de datos que les menciono, que es foro. Y bueno, como resultados preliminares, esto es muy preliminar, hemos encontrado ya diferencias estadísticamente significativas en estos dos genes que ahorita estamos explorando qué función biológica pueden tener. Y bueno, la bondad de esta tecnología es que podemos encontrar variantes en nuevos genes que no han sido asociados previamente con autismo, que son el ejemplo de estos dos, y nosotros podemos ya con el debido estudio proponerlos como probables genes candidatos. Y bueno, la gran pregunta es siempre, ¿no? ¿Qué papel biológico puede tener en los trastornos del espectro autista? Y bueno, aquí nada más lo que quiero darles como conclusión de todos estos estudios que hemos hecho a diferentes niveles es que la comprensión de la arquitectura genética del autismo es muy importante para nosotros poder entender cuáles genes sí están asociados y cuáles no. Y bueno, esto arroja luz sobre los procesos biológicos importantes en la etiología de estas condiciones. Y bueno, también tenemos preguntas muy importantes que surgen, ¿no?, cuando empezamos a tener este tipo de hallazgos a nivel de secuencias. Y el objetivo final, como ya mencionaba la doctora Xochitl, pues es llegar a la medicina de precisión, ¿no?, una atención personalizada para los trastornos del espectro autista. Y bueno, con respecto a la epigenética, la modulación de genes reportados previamente que ya han sido reportados en esta base que les digo de Suari, los CNVs en este locus, que sugestivamente puede a lo mejor abonar al diagnóstico, y bueno, en el exoma encontramos variantes en los genes que probablemente los podamos proponer como candidatos. Y bueno, aquí está toda la gente que ha participado en estos estudios, no lo hacemos solos, hay mucha gente involucrada, y bueno, queremos darles un agradecimiento, y estos proyectos han sido también financiados por POSIS, y pues darle las gracias también a todas las personas que nos han donado muy amablemente sus muestras, ¿no? Para nosotros poder continuar con este tipo de estudios. Y bueno, también aquí quiero agradecer a toda la gente que estuvo involucrada para poder llevar a cabo esta jornada, que estamos en conjunto con Coloretea y con Gama, dentro del marco del evento de Vive el Autismo, y pues todos ellos han tenido que ver también, han jugado un papel importante para poderlo llevar a cabo. Y bueno, las obras que ven aquí, las pinturas son de Ana Paula Humada, y después ya al final vamos a poder ver una exposición de Iván Macías, ya les indicarán los chicos en dónde, y vamos a tener también un concierto de personas con discapacidad a cargo del maestro Daniel Álvarez, y pues agradecer a Victoria Polini, a Xochitl, al doctor Común, que te va a dar su plática, a Nuria y a Diego, y a todas las personas que han estado involucradas en este proyecto. Muchas gracias.
Muchas gracias, doctora. A continuación daremos inicio a nuestra conferencia magistral, Trends and Autism Prevalence and the Research for Environmental Risk Factors, tendencias en la prevalencia del autismo e investigación de factores de riesgo ambientales, a cargo del doctor Eric von Bohm. El doctor Eric von Bohm se formó en psiquiatría infantil y de la adolescencia en Francia. A lo largo de su destacada carrera ha ocupado diversos cargos de relevancia, como científico clínico en el Instituto Nacional de Salud de Investigación Médica. En King's College London, profesor titular y lector académico en el Instituto de Psiquiatría y el Hospital Mountain. Catedrático de Psiquiatría, jefe de la División de Psiquiatría Infantil y titular de la Cátedra de Investigación de Canadá en Psiquiatría Infantil. Se incorporó al Departamento de Psiquiatría de la Universidad de Ciencias de la Salud de Oregon, donde actualmente es profesor emérito. Posee una extensa trayectoria en la práctica clínica con niños con autismo y sus familiares a lo largo de las distintas etapas de la vida, y ha dirigido servicios clínicos para adolescentes con depresión. Sus actividades de investigación en trastornos psiquiátricos y del neurodesarrollo abarcan estudios epidemiológicos, poblaciones y clínicos longitudinales a nivel internacional, investigación de factores de riesgo, específicamente sobre la exposición a vacunas, ensayos clínicos y estudios genéticos. El Dr. von Bohm ha publicado más de 400 artículos en revistas científicas con revisión por pares y 50 capítulos de libro. En el ámbito editorial, destaca su labor como ex-editor asociado en la revista de Trastornos del Autismo y del Desarrollo de 1994-2004, editor conjunto de la revista de Psicología y Psiquiatría Infantil de 2016 al presente, y miembro del consejo editorial de diversas publicaciones especializadas en autismo y psiquiatría infantil. Welcome, doctor.
Good morning, buenos días. No habla español. I am sorry, I will try to speak English slowly and to articulate, but if I go too fast, raise your hand and I will slow down. Okay? I'm very happy to be here. I appreciate
Estoy muy
it.
feliz de estar aquí.
What?
Sorry, would you like me to translate in Spanish?
Oh, okay, so you're translating now?
Yes, yes.
Ah, okay, I didn't know that. But I thought it was Google.
Buenos días, estoy muy feliz de estar aquí. No hablo español, pero voy a hablar inglés lentamente. Si tienen una duda, me pueden decir.
I'm very happy to show you my new hat that my colleague Diego here gave me yesterday, and I will carry it tomorrow at Koyoyakan for the festival.
Estoy muy feliz de mostrarle mi nueva gorra que me dio Diego.
All right. Okay. So, I want to put, in this talk, I will have two separate parts. One has to do with the epidemiology of autism, a review and then a specific evaluation of what is the meaning of the increase in prevalence and is there really an epidemic of autism.
Haremos dos presentaciones, una tiene que ver con la epidemiología del autismo y otra es la interpretación de estos estudios.
In the second part, I will look at what do we know about the etiology of autism and specifically how difficult it is today to identify environmental risk factors.
En la segunda parte veremos la etiología del autismo y lo difícil que es identificarlo.
Okay. So I just want to review the world studies, and here it's just a section of a chapter which is under press, where we reviewed all the studies of the epidemiology of autism, prevalence of autism, done since 1966, which was the first study, up to today.
Esta parte muestra los estudios de epidemiología del autismo desde 1966 hasta hoy.
And the point of this slide is to show you that when one conducts a prevalence study in a given country, the methodology is not standardized. There is no one way to do it. The way you do it in one study is different from the way you do it in another study, because the studies depend on the awareness of the people on the ground, the intensity of local services, the organization of services for medical health, and also the school, special school organization. So everything is different in different countries. Therefore, the methodology to do a survey is always specific to this particular setting, population, country, and there is a lot of variability in the methods used across surveys. Thus, it's very important to be careful when you compare the results across studies to keep in mind that the studies are not conducted with the same methods.
El propósito de esta presentación en específico es mostrarles que no hubo una metodología estandarizada en todos ellos. Esto depende del lugar en donde se hizo el estudio, del apoyo de las instituciones, es algo más local. Entonces es importante mostrarles que en realidad no hubo una metodología estandarizada.
Nevertheless, we could look at trends over time in the prevalence of autism. Here, this is the graph of 165 studies performed between 1966 and 2024. And on this axis, you have the year, and on this axis, you have the prevalence estimate. And when you see this cloud of points, and you can calculate, in fact, that there is a clear relationship between the prevalence of autism and the time at which the survey was conducted. There is a strong positive correlation, which means that over time there has been an increase in the prevalence of autism worldwide. There is no discussion about that. The discussion is, what does this increase mean?
Aquí vemos que a través del tiempo el diagnóstico de autismo aumentó, pero la discusión no se está centrando en por qué, qué significa este aumento en el tiempo.
this one? I'm sorry, I cannot read much. Excuse me, a little pause. This one? Yes. Okay. So when we look at these studies over time, something which is striking is that the proportion of children or participants in these surveys who do not have intellectual disabilities. So those who do not have intellectual disabilities has increased enormously. So most of the increase in prevalence is due to the fact that in more recent years we now include in participants a higher number of children without intellectual disabilities. And this is showing here on this slide very significantly. Where's my translator? She's done. Continue? Okay. Okay, and then if we look at the sex ratio, in all surveys, if you do an average, there is 4 boys for 1 girl affected. And in this slide, I show you that this was the case in 1960s, and this has not changed. It's still the case today that there is a very strong, marked preponderance of males. So there are discussions about females, and I'm not going to get into that, but our data based on population studies show no change in the sex ratio over time, which is what you would expect from a biologically defined condition. Okay. This is just a representation of the world, just to show you some areas where we have some information about the prevalence of autism in some populations. But as you can see, we have many studies This is Europe, many studies in Europe, not so much in Eastern Europe, but they are catching up today. And in the world, you can see there are still areas like Latin America, Central America, Africa, Central Asia, are really areas where we don't have much information yet. But there are many ongoing studies in this country. This slide is 2021, but there's been a big study published in Chile a few months ago, where they had a prevalence of 1.3% as a record. So it's developing, but there are still areas in the world which are a bit behind. I want to draw your attention to this tool. Everybody can use that map. I have maintained that map with one of my research assistants over the years for the Simons Foundation. And you can go on this website and you can click on the dots and you're going to get information about the study, the sample size, the age, the prevalence. So it's just an information tool. If you are interested in that, it's free access, so use it. It's up to date and it will give you some way to consult immediately where things happen in the world. And of all these 165 studies, there was one done in Mexico. In the city of Leon, state of Guanajuato. I hope I said that right. And we did it. I just want to tell you that all these studies, and I have done many in different parts of the world, they take a long time. The study in Guanajuato was started in a meeting in Mexico in 2009, where I was invited, and the ministry talked to me, and then I met Dr. Marcin, and we developed the idea of the study. I get the funding and money to do it from the US, and it took like several years to collect the data, analyze the data, and write up the papers, and the papers were only published in 2016. So from 2009 to 2016, this is 7 years. 7 years of work, what needs to be persistent, laborious. It's not something which you need to engage into if you want results tomorrow. That's not the way it works. You need persistence, perseverance, and it pays back, but in the long term. She's not here? Okay. Is that clear enough? Do you want me to speak slowlier, or is that okay? Okay? Okay, I'll speak like this. So, we did this study, so the team was a team of Clima, with Dr. Marcin, Carlos Marcin, who couldn't come today, he's in Merida, and his colleagues, Norma, Christian, Cecilia, were on the ground, and I was visiting often to help and advise. And what we did in the study, we did a study which was quite sophisticated in terms of the design. We had about we focused on 12,000 children, age 8, in the district school of Lyon. We surveyed specifically the children who had special needs or were in a registry with special medical or educational issues. So we reviewed them all and found those who had an autism diagnosis here. But we also did a survey of the school. So we went into, we said to ourselves, there might be children who have autism who are not a problem in terms of behavior, but might learn at school, and they are in the school, struggling a bit, but not yet identified. And this is an important trend in these studies. So we did that, and we selected a big sample of the normal school. We talked to the teachers, talked to the parents, asked them to complete questionnaires. And those who were high on these questionnaires, we evaluated them clinically, which allows us to have a more comprehensive prevalence estimate at the end of our study. So it was an effort, as you can see, but the main results of this study, in my view, it was a small study, but the first lesson is that it can be done. And this is because often when we start to design these studies, many people say, oh no, here in Mexico, you cannot do it, we never have the authorizations, people will not send their kids. So there's a lot of, and I have this experience in many, many countries. So many people don't believe it, that you can do it, but with, again, persistence, communications, trying to engage people and give them something in return, you can actually do it. So it was a small study, but the main, I think it could be conceived as a proof of concept or a pilot study for Mexico, and we obtained information about the fact that many of children in that particular survey were diagnosed very late. The parents had been concerned when the child were age 2, around 2 often, but many of them waited at age 5 or 6 or 7 before they could be diagnosed. So that we could identify this issue in the region of Lyon. And then we had also a prevalence estimate, which was, let's say, 0.9, it's 1%, it's like 1%. There is a confidence interval, so it's about 1% in this small study that we performed in Mexico in a small population, but that was 10 years ago, right? And I was hoping that there would be new information in Mexico, and I don't think there are new studies or that there is new data. I think that needs to be updated, for the community of professionals working with people with autism and their families and the family associations. And I don't know what's going to happen, but I would certainly encourage anyone willing to embark in that to do it, because you are a country of 130 million people. You're a big country. And this is, as you will see, it is not a very small population. So you need to know how much you have to start to decide what you can do to help this community. And so just to give you an illustration of my point, let's look at this. What I did here, it's not a true study, it's a calculation of Eric Fondel, okay, so be careful. What I decided to do, I said, let's look at the population of Mexico, especially the children under age 20, okay? And I used the data from the census of 2020. So there were 126 million people in Mexico in 2020, okay? I divided by age group this population, and then I just say, let's assume that the prevalence of autism in Mexico today is, let's say, 2%. We had 1% 12 years ago. It was probably too small. So now the prevalence is likely to be 1.5, 2% if we were repeating a study today. So it's just an hypothesis. But with that, you can calculate how many subjects you have, you predict to have in Mexico today with autism. And you can see that in this group is a group of young children under age 5. So this is typically the group which is needing work and resources to detect, screen the toddlers, give a diagnosis of those who need diagnosis, if possibly before age 4, age 3 would be better, age 2 would be even better. So that gives you the size of the effort which exists here to meet the needs of the population. And then on the other side of the equation, you have all these age groups, which combined amount to about 650,000 students in schools who have a diagnosis of autism. And if you don't believe 2%, take 1.5%, and you take 75% of these numbers. So you can play with the numbers the way you want, but whatever you're going to do is going to be a large group of people. That information could be very useful for people who are planificators at the central level, and I know sometimes it works, sometimes it doesn't work. That's a more political issue, but the politicians or the deciders, people who decide how much resources, with which money should go to whom, should be aware of this kind of type of information. So it's an information that can be very useful in your discussions with the authorities when you talk. Okay. If you want that slide, you can always email me and I will send it to you. Okay, if you don't worry. Okay, so other studies in the world. So that was Leon. I did a large study in South Korea, like in the early 2000s. I won't talk to you about the details. Did a big study in China in 8 provinces. It was a very big study with the same kind of methods we used in Leon, except that the population was millions of children. So slightly different in terms of the logistics. And then I also did a big study in Qatar. We terminated that in 2019. Again, same kind of designs. And the point is that all these studies, before you start the study, like in Korea, when I went there, the person who was the head of psychiatry told me, you know, Dr. Fondel, we don't have autism in South Korea. I said, Interesting. I'd like to know, have you done a study? No, but we don't have autism. Okay, we did a study with the proper methods and with the proper concept and definitions of autism, and we found a very high prevalence in South Korea, to their surprise. But we could actually understand why. It was one of the reasons there was a lot of stigma against disabilities and autism in particular in Korea, which is a highly competitive society. And then secondly, the practitioners, the psychiatrists, they were not trained to the modern concepts of autism. So they were using often the diagnosis of, for those who are psychiatrists here, there is a diagnosis called reactive attachment disorder, which is often applied to children who are raised in institutions or raised in conditions of maternal deprivation, and they have, developmental delay of an ADHD, language difficulties. So they develop with some problems which mimic a bit autism, but it's not autism, because in the long term, their outcome is much different. But anyway, so they were using that diagnostic category, and they were doing treatments which were not treatments in the real sense. They were saying, he has an attachment problem, so let's put the mother and the child in a psychotherapy to fix the attachment which comes from the parents, basically. So it was really an obsolete, old-fashioned idea. This is why they didn't have autism, but in fact they had autism like everyone else. So anyway, I have a lot of stories to tell you, but I'm not going. So today, if you look at the world, there is still a number of areas and countries in the world where it's not recognized, it's underdiagnosed, and there is usually a lot of stigma attached to the recognition of autism. The second piece is that, so as I said, when we go in these areas and we do studies with the proper procedures, we find autism at a rate which is what we would expect based on the rate in other countries. There is, in my experience, I've not found in the world any area or country where I could say, here autism is low or is not existing, which would be interesting because that would point towards maybe genetic or environmental factors that might lower the rate of autism. But there is no such evidence that there is an area like this. And the same for, we don't have evidence of countries or areas where there is a very high rate, unexpected high rate of autism. There is no cluster studies in time or in space, and cluster studies are studies which suddenly show you that in a particular area there will be suddenly a concentration of cases that you do not expect, and in the other areas it will be more flat. So there are some studies which have been published, but they are poorly done. But so far there is no evidence. We have not found clustering of cases of autism in population, either by area or space or in time. Okay? So that would be, if we had that confirmed cluster, we would zoom on that to identify what is driving that, but we don't have this starting point. And then here is just a little experience, personal experience. I've assessed children in many different countries, and what has been striking for me in doing that is that they really look alike. So a Chinese boy, age 8 with autism is not different from a Mexican girl of age 8 or a boy in Qatar. So they look very much alike in terms of the pattern of symptoms. Again, this is something you would expect under in a condition where you study a disorder which has a strong biological basis. Okay? So there are some aspects to be considered in terms of culture, which has to do with the way we, first, our instruments, ADOS, ADI, SRS, the common tools that you know, they have been validated in different countries, and by and large, there is some adjustments to make, but by and large, they work as well in Qatar than in the US or in Italy or Mexico. So there is no major change to introduce in the measurement procedure to assess autism. There are a few changes that you may want to do, which reflect the local culture. So, for instance, when I was at McGill, I was going in the Arctic Circle because my hospital, we needed to provide pediatric care for the Inuit population. And they speak Inuktitut and English a bit, but most of them, for instance, when they say yes or no, when we say yes or no, that we move our heads like this. Well, they don't do that. They move their eyebrows, So there are different ways. There are different ways to communicate yes and no. So there are multiple questionnaires which screen for autism, ask questions about does he nod his head or shake his head to mean yes and no. It's a question in the SCQ and the ADI. And so this type of question doesn't work with this population as well. Or in China, they don't have birthday parties in the same sense that we have them in our civilization and cultures, and therefore there is a module in the module 1 of the EDOS. There is a task called the birthday party, and we had to change that in our big study because the Chinese families do not engage in birthday party. They don't plan candles. Yeah, happy birthday to you. It went nowhere. So we changed that with a different task, which was eliciting the same problems, but was a different problem. So there are a few adjustments that you may want to do, but globally, I don't think cultural factors impinge us in doing these studies or doing clinical. Okay. Let me take a pause. I'm going to go to the next one. Okay, much better. Thank you. Okay, are you okay with that? That's the half of the first part. Now we're going to do the second half of the first part, okay? Which is, what does that mean, this increasing prevalence? And is there really an epidemic of autism, and do we need to be worried about something we eat or smoke or which is creating autism? That's the issue. We all have these questions for years. It's not a new question. But last year, the CDC in the US, which provides results every 2 years, because they do a survey every 2 years, presented the results. And then who came to this meeting? The DHSS, who is figured, he's gone. Yeah, this man, he was there, and then he suddenly took the mic and he said, there is autism has increased by 83 times since 1970, and then he said it's not due to increased detection, changing diagnostic, all that is not sufficient. There must be an environmental toxin. And he said, there is a true epidemic, and that can only be explained by an environmental risk factor which is driving these rates up. So that was he stated all the evidence he provided during that discourse was not convincing at all. He didn't actually know much of what he was talking about. But so I was asked by many colleagues to review these questions and put in the same place a series of points challenging his interpretation. So, in brief, we have a lot of data showing that, for instance, when he used these studies, he used that study which has a very low rate, and he compared it to here. So when he do the division, he has 100. But the first study done in 70 is not a prevalence study of autism. It's a guy who looked at the kids who were in clinics with a diagnosis of schizophrenia, and he looked at them and said, oh, that could be autism. And they were all born between 1964. There was no services to diagnose autism. There was actually no diagnostic category of autism in DSM-2 or 3. So obviously, this is a period where any estimate is completely underestimated. It's based on clinically referred. There was no attempt to screen the brain. So it's just wrong, to use that as a baseline. It's by using that, it allows him to claim like it's 1,000 times it's more impressive. Okay? And this is what certain groups of advocates for autism have been doing for years. For example, those who are saying the vaccines are a cause of autism, where all their main argument was to say, yes, it was low before, it's increasing, we're increasing the vaccine, therefore vaccines cause autism. It was based on these false reasonings, and I'll come back to that in a minute. So, if you look at the only series that we have of prevalence that we can really interpret in terms of change over time is the series of the CDC, because the CDC every 2 years surveys the population of children age 8 in the US, and they do that every 2 years with a methodology that they try to maintain constant. It's important if you want to interpret the change, you try to keep constant the method by which you have estimated your parameter. We'll see it's not always possible, but it is the closest that we have. If you look at that, for the first survey published in 2000 at a rate of 0.7%, the more recent rate is 3.2%. So that's a 5-fold increase. That's correct to say that. If you want to put a number in the increase, saying there is a 5-fold increase in the last 25 years is correct. It's based on some evidence. But if you look at the last survey, here, this is the last survey. You see the rate of 3.2% is that rate here. This is this survey, and now we split the survey, and we look at the survey, each state which contribute to the survey. And then you see, you have some state here, California, what do they have? What is the rate in California? Can you see? Who tries? 5%, 5.3%. And look at the rate here. This is Texas, in the city of Laredo, not far from here. Well, so to speak. The rate is 0.9%. So you compare this is the same year, the same population, the same methodology, just two different sites. One is low, one is high. And the variation between 0.9% and 5.3% is 5-fold. So you have here, in the CDC methodology, you can see that even in the same survey, when there is no passage of time, there is no time passing, right? So it's just comparing the survey at the same time point. And you can see that in one site it's high, in one site it's like this, and the difference is 5-fold. That the only explanations for that is that the efficiency of case ascertainment in Texas Laredo was quite low, and then it was quite high in California, or maybe they overdiagnosed, but these reflect methodological differences in the way the methodology of the CDC is applied at one site compared to another site. So you can if that 5-fold difference can exist within a survey at a given point in time, you can also revisit what you think about this fivefold increase over time, because it could simply be a better case ascertainment occurring over time, and you do not need to see that and say, wow, there is an epidemic, because we can see that this fivefold increase is also observed in situations where there is not even the passage of time. So it's like, let's get cool, like Mr. Kennedy. It's not 1,000-time increase, it's fivefold, and even this fivefold doesn't mean that there is an epidemic. Okay? So, etc. He said that, stating that it was because of the inclusion in autism of high-functioning subjects. He said it was not true, autism is more severe than before, blah, blah, blah. That's false, completely false. Everybody knows it. You can see that this is like using the population survey. No, I want to say that. You see, during this period, 70% of participants in the surveys had intellectual disability or mental retardation in addition to autism. When I learned autism in a medical school in 1979, I think, when I saw my first child with autism, and that's what I learned. It was like rare, and they were very severe, and 75% had intellectual disability. That's how we started. But as you can see now, if you look on the right, you can see in the last 8 years, the proportion of people in surveys with autism who also have intellectual disabilities went down very, very steeply, and now it's in most studies about 35 to 40%, okay? Which means that 60% of people with autism in a population pool do not have intellectual disability. Doesn't mean that their IQ, that they can have an IQ between 70 or borderline, as one says, but they are not ranging in the ideal range. So it's a very significant change in the composition of the population of our patients. Now, there's been evidence in multiple studies, I won't spend too much time on that, as services became much more available in the 1990s in most countries, there was more incentive for families to have a diagnosis of autism for their child, because now it started to mean something in terms of accessing support system. Before that, being diagnosed with autism didn't bring any new intervention or new support system to the child, so it was a very different context. But now, the services developed, early intervention programs starting to develop, and to access them, you needed a diagnosis. So many children who had been, waiting for something which had been diagnosed loosely with mental retardation or intellectual disability, many of them were re-diagnosed as having autism. And we have data in California, there was about 25% of children who were in the system for years already with a diagnosis of mental retardation, and they were re-diagnosed as ASD or PDD at the time. And these were the same children, the same in Canada. I can cite you multiple studies on that which show that this exists. There has been change in diagnostic criteria. We all know that the DSM-3, 3R, 4, 4TR, 5 have had change in the definition, and these changes have impacted the prevalence estimates. There are multiple studies again. Here you can just see that study is based on the National Registry of Denmark, and they estimated that when they switched the diagnostic system from ICD-8 to ICD-10, that shift in itself led to a sharp increase by a third of the increase in the number of cases of autism in their registry was directly attributable to this change of nosography. So it's an administrative switch. And that, again, has no biological meaning and shows once again that the prevalence might increase for reasons that have nothing to do with an epidemic in the conventional sense. Here you can see it in the CDC data, the sites who have the highest rates, California, or the sites which have the lowest rates, are sites which are very different in terms of their policy. In Alabama, for instance, Alabama is a state in the South. There is no money for kids with disabilities. It's a Republican state. I'll stop here. But there is no support and they don't care. And then the prevalence is low. And then California is all the contrary. In California, at that particular site, they implemented a very proactive screening of children at age 12 months and 15 months and 18 months, referring them immediately for an assessment without waiting time, and then if confirmed, referring immediately to treatment. So it's a pilot project that they have implemented in their community where they are proactively screening, detecting early, and intervening early. And no surprise, if you do a survey there, you have much more prevalence. So it's just a slide which shows that the prevalence that you get is also a reflection of what's happening in terms of the screening and early detection on the ground. Okay? And then I know it's a day for the adults, so let's talk about the adults. Another reason why the prevalence might be increasing is that some adults would many adults today who have an autism phenotype or diagnosis were there when earlier surveys were conducted, but they were not diagnosed. So there's been we know all that a certain number of adults with autism have not been diagnosed when they were children, and that some of them now, with the increasing awareness, decreasing stigma, more interest for the adult population, there are now diagnostic services for adults. And here you can see Sochil presented data on the prevalence in adults, which was around 1% in the first UK study. But here it's the same. It's a study of, there are, in that analysis, there are 30 million people, and it's all the population of Medicaid. And so you can see here is, this point here is the overall prevalence in the whole group of adults aged 18 to 99. And then in 2019, the overall prevalence is almost 1%, almost, okay? But now that is mixing up the young adults, the middle-aged adults, and the older adults. If you break down this rate by age group, you can see that here, this is the group 18 to 24, and their rate is almost 1.8 or 2%. Okay, and then if you look at those older groups, of course, the rate goes down because they have been less diagnosed the older they are. But the other thing which is of interest is that you see here, this is a cohort of adults of age 25-34, but in 2011 the rate is like 0.5%. In 2019, in that same age group, the rate is now 1.4%. And then in 1 year, there is an increase of plus 0.2% point of prevalence in 1 year in that age group, which means that this 18 to 24, they have like a certain prevalence, and then you move 1 year later, there's a number of them which were not diagnosed, have now been diagnosed. So more are now coming just from year to year. This is happening in all birth cohorts. at different rates, but it is happening everywhere in all data sets that have been able to consult. So it is happening. Many adults now who are not diagnosed before are diagnosed. But now, again, think about this. If an adult is diagnosed at age 30, it doesn't mean that the person has developed autism last year. This person was autistic when she was a child or he was a child. And it means that she has gone under the radar up to now, and where she's diagnosed at age 30. Which means that when we are doing surveys, before, there were a number of people who were undiagnosed. Which means that the prevalence is increasing because now we are recognizing more and more. Okay? So that's kind of a way to present the adult data as evidence that they must have been there before, but they were not accounted for. And therefore, our past prevalence estimates were underestimated. And because the mechanism of this misidentification is purely human-based, it has no biological meaning, so we can again not say that this increase in prevalence due to late recognition of autism reflects a biological epidemic type of thing. It's just a question of changing the rules and changing the identifications. Okay, so at the end, like going back to Mr. Kennedy's pronouncement, he said all that. Then in this, I took one by one his arguments and showed that in fact each of these arguments could explain itself a doubling or tripling of the prevalence. And basically I conclude that he was wrong on everything. Bye. Okay. And so this, if you want a more detailed explanation of this particular issue, you can look at this article, which is a direct response to Mr. Kennedy's statement last year, and a bit like I did too. Okay. Are you okay?
Yes.
Not too fast?
No.
Okay. Okay, so now second part. The first thing is that I want to count, I am a clinician. All the work I've done in research has started with my clinical questions, and the results come back to my clinical body, so I'm very clinical in mind, and also I'm interested in multiple aspects of autism, as we all are. So the genetics of autism have been incredibly transformative in the last 20 years. And again, I've been participating to that actively, and I still do, but I'm not myself a geneticist. So, in terms of the genetics, there are a number of arguments to remember. The first argument is when you want to quantify how much genes are involved in the etiology of a condition, one way to do it is to compare twin pairs. Okay? You take a twin pair, you take two boys who are monozygotic, they are 100% genetically the same, and then one has autism, and you ask the question, what is the probability that the co-twin which is identical, has autism as well? Answer, it's always a range, but the answer, the best studies is 85 to 90%. So when you have monozygotic pairs, when you have one autism, you can be rather sure that the other one will have autism as well. Now, this is the starting point. Then take a pair of two boys, but they are dizygotic, fraternal twins. They just share 50% of their genes. One has autism. What is the probability that the other one has autism? about 15–20%. Okay. So let's say it's 20% compared to 90%. So the difference of concordance between these two types of twin pairs is a direct measure of the impact of genes on the etiology of autism. It shows the difference in the risk that you have when you only share 50% of the gene with another person compared to when you share all your genes. Okay? So this difference of concordance is used in many aspects of medicine and allows us to estimate the heritability of autism to be about 90%. Which means that 90% of the population variance of autism is due to genes, so it's quite a bit complicated. But it's a matrix that, if you compare that to other conditions like schizophrenia, ADHD, bipolar disorders, autism is higher. So it's more genetic than the other conditions that we know which also have a strong genetic component. So that's one thing. The second piece is this one. In this study, people have looked at families. A family has a child and he has autism, okay? And then the family continues and they want a second child. So these families have been recruited for research so that we could really estimate with precision what is the risk of autism in a child who already has a sibling diagnosed with autism. It should be probably higher than for the general population because it comes from parents, and if there is some genetic factors, the risk should be higher, right? So they are called baby SIBS consortia, and there are 3 in the world, and they work together, and then there's been one study and a replication on Lou entirely sample recently, which converged in estimating the risk in the second child born in this family to have autism is raised. It's not 2% like the risk for everyone, it's 20%. So the risk of another child in a family when there is already a diagnosed child from the same parents to have autism is 20%, not 2%. 2% is the risk for everyone when you don't know everything. 10% is the risk in someone when you know that this person has an older sibling diagnosed. So, okay, if you do conditional probabilities, you understand. So it's 10 times the risk for autism. So that's a profound demonstration which support the previous thing. So, this is, I can tell you that as a clinician when I started, we had zero genetics to do. There were some translocations on chromosomes that we were sometimes looking, but we didn't have microarrays, we didn't know Fragile X, we didn't know CNV, so things have changed incredibly, and especially in the last 20 years, because the techniques of genetics have improved considerably, and we are in a better position. So we did not know much now, and now we need a lot about the genetic underpinnings of it. Right? Okay, so it's complex. I'm not gonna. Sochi has covered that as well very well. I think it's important to know that also the genetic propensity to autism is also shared with other conditions. So ADHD, for instance, or depression in both sides of the family, paternal and maternal, is raised in autism. And the association with ADHD is quite strong. So you have often a situation where you can have a child with autism and the brother or sister is not affected with autism but has ADHD. That's a very common configuration. Okay. Look together. Okay, I just want to take 2 minutes to talk to you about a study called SPARK. SPARK, we started that in 2016, and the reason was that we did studies before with 5,000 families, so we were, after analyzing like a lot of genetic data, we realized that it's very complex. The genetic architecture is complex, plus autism is also complex. It's a very heterogeneous condition. We know from past experience, like in diabetes or cancer, that really to start to understand the minor genetic variations which are in the population and are contributing to the risk, to detect them, we need very large samples. We need samples of 100, 200,000 people with autism, if not. So that's why we started this study in 2016. We were, you can see I was here, but most autism centers in the US joined. We were all in the same study. It was funded privately by the Simons Foundation. And look today, so that's today. So in 10 years, now we have 450,000 people who are in the study. These are parents, children with autism or adults with autism and their siblings. Okay? But so there are 175 individuals with autism, and of these, 37,000 adults. So we have achieved that in 10 years. It was unexpected. Most of them have genomic data, not all, but most. And the way it works here is it's very easy. The people receive some information, and they can do that from home. They go home, put the website, they complete information about the parents, the family, the child's development, the diagnosis, so all that gets into the system, and they agree to be participating to the genomic collection. So they just said, do that. That the data go in the centrally, and then we sent to the family saliva kits. So there is a big FedEx envelope which contains a saliva kit for the father, for the mother, for the child who has autism, and siblings when they do. There are videos on how to do it well. Then they do it, they put it back in the box, ship it back. They have no cost. And when we receive the things, they have an incentive. They receive I think $50 card for Amazon or something like this. And then we analyze their data, and that has been working very well. And one of the beauty, two things are important. So we analyze their data, and maybe that we don't find anything. But what we do with this data, we reanalyze them 2 years or 3 years later, because now we have new information of certain genes that we didn't know, and then we reanalyze it. So these people will be reanalyzed. There will be an update of their genetic analysis over time. Right. All other things, we analyze the data and we find a variant, we search it, we repeat that, we do multiple checks, and then we are convinced, clinicians and geneticists say, yes, that gene has never been reported in a non-autistic person, so we have criteria that this variant is likely causing autism in that child. We need to let the family know. So then there is a return of results to the family. The family can say, okay, you can send them to my doctor and it's going to be my medical record and I'll talk about them. Okay? Or they prefer to get that for themselves, not for the medical record. And we pay a consultation for the family and the genetic counselor so they can have an explanation of that, the implication for the families, for the siblings, and then that's it. And then there are other things as well. But it's a study which is quite smooth, and I spoke to some of your colleagues here, because we have now the experience of doing successfully that in the US. So if you're going to do that at one point here, there are people there who I'm sure would be happy to show you what worked, what didn't work, so that you can not duplicate the you can go on the website. There is a list of genes that we maintain that is up to date. It's very informative. Okay, now this part is that this is really the crux. So the thing I want just what I'm going to say is that now we're going to move to the association with multiple things. You're going to see, and what I want to discuss is that most of the things which have been published, the risk factors, are not causes of autism. They are just statistically associated with autism. We call that an association. It doesn't mean that these are causal associations. It's very important because many studies on the web say, oh, living next to the highway, oh, high pollution, or diet with no leucovorin or whatever. And then there's usually one study was done here, and each study in epidemiology it's not an experiment, it's like observation. So we just collect the there is ample opportunities for bias to always creep in. So when you have a statistically significant association, well, you can be happy, but it doesn't really say anything about does that risk factor or this thing is causing autism. You need to do much more for that. And that's what I want to explain here to illustrating that. First, I want to go back to the vaccines because I heard one of the big false theory which was developed was the vaccines. 1998, this paper by Wakefield said the MMR vaccine triggers autism in the child. And then in the US, there were people saying, oh, all the other vaccines, not MMR, but the other ones have a small amount of mercury, which was used in vaccines to prevent bacterial and fungal contaminations. It's been used for decades in blood supplies during the war, blah, blah, blah. So they say, oh, there is too much mercury. And so independently, they sort of said, well, vaccines, if it's MMR or the mercury in the other vaccine, they are the culprit. And one of the main... Okay. So I will pass that. I was very involved in that, in research and also in litigation. But basically, there has been no controlled study, well executed, which has shown any association with MMR. So taking MMR is safe. Here, you take these children here. You see, it's not MMR, this is mercury. This is the amount of mercury in the vaccine. So that compares children who had no vaccines which didn't contain mercury, and those with contain some degree of mercury. In fact, the risk is not different. It's likely to stay. It's the same, essentially. And then you can see if a small dose, medium dose, high dose doesn't change the risk. There is no association with mercury. Okay? I'm happy to, if you have questions, but I can talk to you more than I would wish. But and then if this is another study. Study we did in England, because I met Wakefield a number of times. I was in England there, so we did a study immediately when he made that claim. It was a big case-control study of 4,000 kids with autism compared to a high number of controls. And then we looked at MMR, and then the results are here. So that's the adjusted one. You can see when vaccinated with MMR, you don't have your risk increase at all. And it's true for autism or PDD at large. So there is absolutely zero association. I can cite you many studies. The epidemiology has been done correctly, immediately. All studies have failed to show an association, either with MMR vaccines or with any content of mercury in the vaccines. By the way, the mercury has been removed from the vaccines in the US in 2001, effective in 2004, and it has had no impact on the rates of autism, which have continued. So people who believe in that say, oh, you will see, when you remove mercury, it's going to drop. Well, you see, it has not dropped at all. Yeah, because it had no relationship. Okay? So be very firm on that. There is no association between these two. So the paper by Wakefield was retracted officially. It took a long time, but in fact, it was shown that his research was fraudulent. He actually manipulated the data and the people. He has been expelled from the UK medical board, but his name is now coming back in some new endeavor. So he's still here, acting in the shadows. Anyway, so that's it. And this book tells the whole story. It's a bit of a tedious. I just want to always, when I do talk about vaccines, I want to remember you. You know, I had measles as a child. Maybe many of you didn't have measles because you were vaccinated. So today, you don't recognize measles. You don't know what is a child with measles. And many doctors do not know what is measles. So it's bad. It's actually very bad. It's a bad disease. It actually kills children. It's about 1 or 3 in 1,000. There has been in the US last few months an epidemic of measles. In Texas, people did not vaccinate, and 3 children have died. 3 have died, and 3 more have died from whooping cough, which is because they didn't vaccinate against whooping cough. So be aware that it's bad. I don't know, I just want to show you. Whooping cough, you don't know. Let's see if that works. It doesn't work. Well, it's on YouTube because it's a whooping cough, coughing in a little child, and you just need to see it to understand. It's so good to be vaccinated. You don't die and you don't have this horrible disease. Okay? Well, okay. Okay. So for families, to be clear, first, no parents should know or should say that maybe my child became autistic because I used this vaccine or because I did something with the vaccine. No, there is zero evidence of that. So parents who have vaccinated correctly their children did the right thing, and they have not increased the risk of autism in their child. When there is no evidence of MMR, you should vaccinate your child. Even the child with autism should be vaccinated. He's like any other child. He has medical needs, and we need to protect him against bad infections. So do vaccinate, and vaccinate the siblings, because many parents say, oh, it's too late for my boy, he's already autistic, but this little girl, I'm not going to vaccinate her with MMR because I want to wait the age of 3 or 4. So they do all this reasoning, which is completely based on anxiety and not evidence. And when they do that, or they say, I want to separate the shots of the measles and the mumps and the rubella later, each of these approaches have been shown to lead to lower intake and incomplete vaccination in young children. So by opting to do this, parents in fact do not spare their child from an autism risk increase, but what they do, they expose their child to an increased risk of infectious disease that could be easily presented, and many of them do lead to complications and sometimes death. So it's really not advised to not use them. Okay. So, as I said, many of this belief that vaccines could cause autism was based on this observation. The rates of autism are increasing. Oh, the number of vaccines we give to young children has increased during the same period. So you can do a correlation of these two numbers, and you're going to have, what? 0.63. This is fictitious. I made up this data, okay? But the problem is that you can change the mercury. Oh, now I put cell phone cells. Oh, it's correlating as well, 0.72. Maybe it's the cell phones, or Mexico national debt has increased. I don't know. Sorry if I offended you, but okay. Maybe that's it. It does have a significant correlation. And then, sneaky, maybe not going to church is significantly negatively associated. Could it be that autism is a kind of punishment for not being as religious as you were before? You can speculate about any explanation, but the point of departure, the starting point is that it's just taking a series of group estimates and correlating that with another series. You're going to find that everything which changed will correlate with the thing which changed, positively or negatively. But it doesn't give you any hint about why do they actually are related. Is one causing the other? Zero. You cannot do that. It's a well-known fallacy we call that technically the ecological fallacy. Okay? Because these are, what is correlated here are group rates, but we never know if the children in these groups were vaccinated and had autism. We don't have information on the individuals in this group, we just know the global rate of autism or the global rate of vaccination. But that doesn't tell us the critical information we need about individuals. Okay? So that's out. So when you go to Autism Speaks, I went there to look at their website, what causes autism? What causes autism? I don't know all of this. One of this, it is very, very complicated. Now, this is like on the website. Now, if I looked at the risk factors during the prenatal period, I started to do a list saying what has been identified. Say, SSRI exposure, smoking by the mother during pregnancy, air pollution, living near a highway, lithium in the drinking water, studied in Denmark, C-section, maternal diet, and I stopped because I could have 2-3 slides on that. So there are many, many, many external factors which have been associated with autism. But what is remarkable when you look at that, what does unify them? They are completely disparate, right? There is no unifying pathophysiological theory that you could invoke to explain why these many factors would be associated with autism. So it makes no good sense. Okay, so I'm going to use some illustration on these later in the end of the talk. So here so the next few slides are a bit technical, so I'm going to try to speak lightly about them, but later I will use examples that will explicate what I mean. Okay, so bear with me, and okay, so the principle here is that, again, an association is just like a correlation. Okay? You see now the papers, when you read papers, they use very sophisticated modeling techniques like intention to treat, or what are the other things? There are other statistical techniques that you could use to make adjustments, so it's sometimes very complicated to do. And then you have an adjusted estimate of association, which takes into account the role of background factors that we call covariates or confounding factors. But it's very hard to follow, but at the end, you only have an association, which is numbers that gives you a sense that they go together, they are correlated, even when you control for something, but it doesn't prove that X is creating Y. So X and Y go together in this data set. It doesn't mean that X is creating Y. Okay? You need other kinds of evidence for that. So the usual question is that, does this exposure cause autism? So we collect data, we have various designs, cohort studies, space control studies. We create estimates of association using measures which are called odds ratios, relative risk ratios, hazard ratio. These are just a correlation. It's like correlation. Take that as correlation. So we have a study. Let's say exposure is maternal smoking during pregnancy, and the disorder is autism. I've collected the data. I did a case control study, and the mothers who had a child with autism reported that 40% of them smoked during pregnancy, and the controls said 5%. So there is an association between having smoked during pregnancy and autism. That would be the type of thing. So you get there and you have that. But what does that mean? Have we found a cause when we have that? Answer is no. So this is like a bit of a mathematical drawing, but just bear with me. So what we are interested is does smoking cause autism, right? So when you see that, it could be causing autism. Maybe smoking creates low birth weight that creates autism. So it would be a mediating path, okay? So the direct cause, mediated cause. But you can see here what are the causal paths are this path from E to D, or this path from E and D. Now, there is this guy here. This guy in blue is named confounder. It's a variable which is in the background, which is associated with smoking, but also associated with autism, but C does not cause autism. Okay? It makes E and D co-vary together because it's associated with the two, but it's not a causal autism. So when we do our study, we are actually estimating an association which is a global association, and in that there is the causal component of this association, this part, and this is what is of interest to us, but it's also parasited by the non-causal effects which are captured in the association. So we have an association, but it does not reflect only causal mechanisms. Okay? So again, I said multiple statistical techniques which are complicated to read are available, but they will not address the fundamental questions. Of course, they might adjust things, remove the effects of some variable, but they will never get to a point where with them you can demonstrate causality. So I'll skip that because it's a bit complicated. So let me give you an example of confounding, which has been illustrated in our field in recent years, especially with the studies and the claims that were made with maternal mothers taking antidepressants during pregnancy. That has been around since 2011, the first paper. Probably about 30 studies published so far. The latest show that it's confounded and not a causal one. But it took time. And this more recent one is a Tylenol. Acetaminophen claimed that mothers who take Tylenol during pregnancy might increase the risk of autism. So anyway, so this is like a study of mothers taking SSRI. So you see the adjusted hazards ratio is 1.6, and because it's very different from 1 is no association. This is 1.6. and it is what the interval of confidence is such that it's a significant association. So there is a significant increase in the risk of autism in mothers who took an antidepressant or an SSRI in that data set at this stage. Okay? Now let's look at what they did next. Next, they asked the question, there is an association. Is it that the drug is increasing the risk of autism? Or is it because the mother is taking that drug because she has a condition which is associated with autism, but the drug is not? Okay? So how do we study that? They decided to look at just at mothers who had depression or a history of depression. Now everybody is equal. All these mothers have a history or propensity of depression. And then in that group, you separate those who took an SSRI during the pregnancy with a history of depression from those who have the same history of depression but did not take SSRIs. So here you can compare like with like. All these mothers of the pairs are the same, so the genetic risk of depression is spread equally across the two groups. The two groups are made comparable because they are matched on maternal genetic background for psychiatric care. And then, when they do that, the kids were treated with SSRI versus non-treated, there was zero effect. So this is appearing here. You can see here, before this new analysis, they have a significant association. Now, this is only mothers with a history of depression. Some took the SSRI, some not, and the risk now has decreased and is no longer significant. And there is another analysis later which is even more convincing. So and we do that often. And the latest, the thing with acetaminophen is one of things. Okay, so another complicated slide or two, and then we'll okay, so you see, I came back to this confounder. The problem with confounders is that sometimes you can remove their effect. In the example I gave you, they could remove the effect of maternal depression because they had information on it. But suppose they didn't have data on depression or whatever. So, and it is the case in most studies, there are confounder factors which operate in life, in reality. If they are measured, and measured well, we can adjust on their effect, but many are not measured. They are just there in the nature. Maybe we know them, but they have not been measured in our study, or more likely, we don't even know them. So they have not been measured. So we cannot, when we have an observed association, we cannot be entirely sure to deconfound this association because we have this family of variables which are confounders there, possibly mixing up this association, but we are impotent to do anything with them because they have not been measured. Does that make sense? It's going to be more explicit with the example. Okay, so we have two examples I want to give you of techniques that more sophisticated epidemiological studies can now apply to move away from this thing, there is a statistical association with pollution and blah, 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 and make over-interpretations of that. Then move away from that and doing much more finding associations, but when you find them, try to test them for and refute them, and refute their causal nature by using this technique. So one of them is, again, taking SSRI during pregnancy. Look at this one. Mother taking SSRI during pregnancy. The hazard ratio here, the risk ratio is 1.4. It's almost significant. Let's say it is significant. Okay? It's 1.40. Means a 40% increase in the risk of autism if the mother has taken SSRI during pregnancy. What did they do? They say, okay, if this is a real association, the mothers who took SSRIs before the pregnancy, but not during the pregnancy, should not have an increased risk. If this is a medication which is the culprit, then mothers who have taken the medications before becoming pregnant should not have an increased risk, especially if there is a long period of eliminating that. So if the mother was depressed and took SSRIs 2 years before the pregnancy for 1 year, and then she stopped the SSRIs, the SSRIs after a few weeks is completely eliminated. When she conceives, becomes pregnant, she doesn't take SSRIs. So you see the interest. You can compare mothers who take SSRIs when they are pregnant, and you find some who have taken historically SSRIs, but not during their pregnancy. And the prediction is that if this is the medication which increases the risk of autism during pregnancy, we should not find an increase in risk when mothers take SSRIs but outside the pregnancy. Because of medication, there is no medication during the pregnancy. Does that make sense? I've explained that. So that's what they do. Look, they do that. They use mothers 2 years to 6 months before pregnancy, but they stop taking any medications. What is the risk? It's like 1.46, 117, 181. So, what does that mean? Now, you can see the risk during pregnancy is 1.40, and then before pregnancy, it's the same. That means that this association between taking SSRIs and autism is driven by other factors than a direct effect of the drug. So the direct effect of the drug during pregnancy is disconfirmed by this analysis. It's the same data sets. They just had this idea to look at periods of exposures which were helping them to test the mechanism for the association observed and refute the direct association. Yeah? Okay. So that's what we call using negative controls. Okay. And another types of negative control is another illustration. Maternal mothers taking antidepressant and their risk for autism was elevated, significant, 1.72, okay, during the first trimester. Okay, what do we do next? Okay, and then but they again looked at before pregnancy, and you see 172, 149 is still high, it's still significant. It's again a case where before pregnancy, yes, there is also an association, so it doesn't seem to be a causal association. And then the other thing that they did, they used another type of negative control, which is to take the father's exposure to SSRIs. And that's what they did here. When they look at the fathers, you know, they have an association with autism which is almost significant. It's like almost, you could say it's almost significant. And how come could it be that there is an association between the father taking during pregnancy some medication for himself that doesn't go in the womb and the fetus, right? It stays in it. It's still associated with the risk of autism. So that shows that this association cannot be causal and a marker of a direct impact of the drug on the fetus, because it's impossible. It's just impossible. So that's another type of negative controls that, when used, many of these associations which show up initially, they disappear. Excuse me. Trying to be a bit illustrative. Okay, so and look at ADHD. If you look at the slide, ADHD is the same. There is a lot of false associations, false causal association initially suggested, and when you test them with negative controls, you show that it must be confounded by other things. It's not possible. So this is a bit. Okay. What time is it? How much? 11:51. So do I have more time? Okay. If it's not, I know it's a bit dense, but you can repeat it. Okay, so this one is like thinking about genetic factors. Okay, because we have a tendency to when you see something happening during pregnancy and that there is an increased risk of autism, we think these things did something to the fetus and then led to autism. It's kind of, we almost do that intuitively. So that's what it is. So you have the pregnancy period here, and then you're going to do something. Let's say again, take like smoking by a mother during pregnancy. Smoking, she smoked, we look at the outcome of the offspring, ASD, and then there is a significant association. Okay, that's what we discussed before. Now, the logical thing to do is that we think there is a direct intrauterine effect. She was smoking, the smoke has like PM2.5, particulate matter, nitroxide, all sort of bad things that impinge directly in brain fetal development during the pregnancy. Okay? That's how we often interpret these associations. Is there another pathway that could explain this association? In fact, there is another one, which is like this is the one. This is a one which is mediated by genetic effects. So bear with me. Maternal smoking can be influenced by maternal genes. We know that. There are multiple studies showing that mothers who smoke during pregnancy have a particular genetic profile, which is not common. These genes of vulnerability to smoking of the mother are passed on passively to the child. And then, because the child has genes which are associated with smoking, but also with this association, there could be just a path of maternal genes to child genes to the ASD outcome. So, in effect, what I'm saying is that it was maybe a bit too critical. Mother smokes, and the child has ADHD or ASD. It could be that the smoke of the mother directly impinge on the child's development during the pregnancy, or it could be that the mother she smokes and she has a lot of issues, she has a certain lifestyle, all that is influenced by her genetic background. This genetic background of the mother influences her behaviors, how she smokes, how she eats, and her lifestyle is influenced by her genetic signature profile. And some of that, half of that at least, some of that is passed to the child. And if the genes of the mother which are involved with smoking are the same that are also the same that increase the risk of the outcome, then you have a situation where certain genetic vulnerability can predict that the maternal exposure to smoking will be high, that the outcome of autism will be raised, and there would create a correlation between the two, which is not due to the effect of smoking on the child, which is due to the fact that they share the same. Trying to dance. It's the same genetic effects, and we know in autism that there is a lot of overlapping genetic factors between different disorders. There is multiple evidence that the genes for autism are overlapping with genes for ADHD, for instance. There is a strong overlap between the two. There is also a strong overlap with genes for adult lifetime depressions or history of mood and anxiety disorders, autoimmune disorders. So there are genes which are increasing the risk of autism, but also increasing the risk of various things implicating the health, medical, and psychiatric of the mother. And therefore, when we see these factors in the mother, we should not naively interpret that they directly affect the child, that this may be just that they share the same genetic background. So given that, when you see that, when you see that, you're blind, you don't know what's happening, you don't know the mechanism. You say, maybe it's that, or maybe there is that, or maybe it's the two. So it's very hard to disentangle what does what. But the significant association is a kind of product of the direct effect, if it does exist, and shared genetic effects if they do exist. So we need particular techniques to adjust on these genetic background factors. That's what everybody is trying to do today. Either we have genetic samples from the mothers and we can calculate what we call polygenic risk scores and use that as providers, so there are multiple techniques. But even when you don't have that, you can use epidemiological techniques by looking at subsamples, when you have them, which can control for the effect of this background genetic factor. Even if you don't measure them directly, you can limit their effects. Okay? And then, therefore, increase the interpretability of what you find in fact. That's what it is. And the way to do that is to do what we call sibling comparisons. So now we're going to take the SSRI. Take a mother with a history of depression and the risk of autism in the offspring. Okay. We've discussed before, if you do that, usually you have a small signal that it's associated. Now, one good question is to do, let's take mothers who have a risk of depression and find mothers who have two children. One, when they were taking SSRIs during their pregnancy, because she has a history of depression, and then there is another sibling where the mother did not take the SSRIs because she was not depressed. So now we have two pregnancies with two outcomes. These pregnancies are matched on the same genetic background profile of the mother, so that does not play a role any longer. And the only difference in terms of the two outcomes you observe in the group is going to be due to the exposure during pregnancy, whether she smoked or did not. But this contrast now is done to re-evaluate the association, but controlling for the fact that the genetic factors are shared between the two siblings, and therefore they cannot confirm the association. Yeah? It's a bit tortuous, but I hope you can translate that to Spanish. I couldn't do it. Okay, so that's an example. This is still the antidepressant. You've seen that slide. 1.6 when you do nothing. When you adjust on the maternal depression history, it goes down to 1.4. But when you look at, sibling comparisons, so these are just siblings, 2,700 families with siblings which are discordant for exposure to antidepressant. Means that there are pairs of siblings, and each pair there is one which was exposed to SSRI, the other one was not exposed. Okay? And then you recalculate the risk, and this is like 0.9, which is completely non-significant. It's not even 1.1, the time there is no association. So that is very telling. And the acetaminophen Tylenol claim of 22nd of September 2025 by Mr. the President of the US and his DHHS delegate, they started to say, don't take Tylenol, it's bad, like mothers, be tough, don't resist to pain, don't use medication. And there was a big study by Amquist, that went out in 2024, obviously not known by Dr. Kennedy, not Dr. Kennedy, Mr. Kennedy. And you can see that they did a general analysis like this would be a significant association, correlation between taking acetaminophen during pregnancy or not. But when they looked at, we did what we just showed, the sibling analysis, restricted to the same mother, two siblings, one pregnancy with acetaminophen, the other not. When they do that, the risk is 0.98. It's not different from 1. It's not significant. There is no effect. And this finding only emerged because of the beauty of the design of this study, which went steps further to disentangle the mechanisms that are encapsulated into a correlation or an association. And by doing that, they showed that the causality is not a concept. Okay, so same thing, there was another study from Japan, same thing, they did that, and they have no association whatsoever, and rather the association disappears. The thing to understand is that in this sibling comparison, the correlation or the association which is seen is one which, compared to the previous ones, is adjusting for the genetic effects. Okay? It adjusts to the genetic propensity to autism in the kids of this mother. But if we ignore that, we got like observations of correlations which are significant, but clearly they are not causal because of these sibling comparisons rule out a causal mechanism. Okay, so I think I'm going to maybe stop here because I don't want to be rude. If you are interested in this approach, there is a big paper published last year by Nature Medicine. It's a large group of Scandinavian researchers where they have these big national registries where they can do epidemiological studies with millions of participants because the data are already collected. And they did that, and they did systematic. They looked at all the maternal conditions or disorders during pregnancy, and they looked at them whether they were associated with an increased risk of autism. First step. Second step, they did multiple negative control analysis. They looked at the father's things, as we said. They looked at the association with the father and the outcome. When the association was seen as well in the father, it showed that it was not a causal association with the mother, so they excluded those. And then they did sibling comparison, because they had a large sample size, where the sibling comparisons are the ultimate test of re-evaluating the association once we control this time for the shared genetic factors which are involved with the outcome. And when doing that, virtually all the maternal conditions initially selected disappear. So it's a really important paper in terms of what it proves is that, and certainly in terms of reading the literature, it gives you some ideas on how cautious one should be when we see a study, oh, we find that pollution, lithium in the water, blah, blah, blah. Most of the studies do not go far enough to try to rule out confounding factors which are unmeasured or uncontrolled. They don't do sibling comparisons or other techniques, and therefore many of these correlations are meant to disappear with time. They will have a short life, not linear one. So I don't want to maybe bother you with that, but basically what I'm trying to say here is that there is a word that we use now, it's like a triangulation. So when we try to, when you look at, let's say, does maternal smoking increase the risk of autism? You need to look at studies where you have this correlation association, but they are biased because they don't control for genetic factors. So you need to look at, you need to identify in the study, these studies are great, but these are just statistical associations. They don't mean necessarily that there is a real biological causal connection between the two. What do I need to be convinced of that? Oh, I need a study which adjusts for shared genetic factors. Is there a study where they did that with sibling comparisons, with good power, good control of other factors? Oh yes, so it's this one or this two one, and they this one showed no effect, but this one showed an association. So these studies much better design, adjust on many more bias than these ones, and they show a negative factor. If, on the other hand, you have studies of a certain kind, we all have some deficiencies, but studies of another family of studies which have different kinds of design and different types of sources of bias or limitations, and then a third kind, which has yet another kind of source of bias, not comparable to the first one. It's like the triangulation which is here, which is, you see this three thing? They try to measure something on this like big peak, there is pyramid in the middle. I say pyramid. And you see, they are different. This is a woman with a certain type of thing, and she's below. That is, I don't know what, a special tank measuring thing. This is a thing. So there are three measurements. Now think about what is a replication. Much of our field now does, someone finds something, and then someone goes, oh, I'm going to replicate that result. And they do the same thing that the previous person. Maybe they change the instrument. Maybe the age is slightly different. Yeah? And they do the same thing, and they find the same thing. This would be as if, in that study where measuring that is very difficult, this one, she will never get it right because her position, her techniques is insufficient. She's going to measure something and other things will be wrong. Same for him, same for him. So, if suppose that the first study, first measurement, then add more girls like her. If you have another person doing the same thing here, or practically the same, it's called a replication. So we have a lot of replication in our field, but the replication performed from here going to have the same limitation than the limitations of this one. So just the fact that you find results that replicate does not mean, should not increase your confidence in the reality or the veracity of the causal relationship. Okay? Because you have repeated some kind of procedure, fine that you should find the same thing. But if at each time you do it, you miss the point because you're too low or you use an obsolete measurement tool, you're going to never get to a real answer. So understand if you replicate this or this. Okay? But if you combine, so see, this one has advantages over this one, so different sources of bias than this one, and this one has different sources of bias than the other two. So by triangulating the measurement and using approaches which vary in their accuracy, you're going to have a much better handle on measuring this guy. So it's basically bringing people from different angles to get a better impression of what you want to measure. As you can apply that to the field of epidemiology at large. And I think that calls for us, the investigators, also to have more responsibility when we have these studies that we show, pollution, living near the highway, all that stuff. Come on, I mean, our task should be first say, okay, we have a significant finding. Let's discuss what we didn't do, where we did not control for, and all the reasons why this study is at the very best preliminary and needs to do other things, other studies with different sources of it, not me, other people with different measurement apparatus, and then if we all find something which is consistent, then we'll talk about causality, but not before. So I think we should be more responsible and not jump onto conclusions about causality. And when I'm editor of journals, so I see that all the time. The people say, in their discussion, they say they spend hours trying to explain why their findings are so good, why the confounding factors could not explain the findings, why and then at the very end, like the last 2 lines, you see, our study is just an observational study and we cannot talk about causation. And they say that, but then the harm is done. They have presented their study as a super study that is demonstrating almost causality. So I think there is a kind of an over-enthusiasm sometimes by investigators to present themselves as if they were really evidencing causality when they really don't, and we should switch on. Okay, so this is all it is. And then, so all that at the end, when I look at the literature, there is very little that remains. If you have very stringent criteria, I think the one advancing parental age, exposure to valproate would be two risk factors which I repeatedly said, well, yes, there is something there. The mechanism for the advancing parental age are likely an increased rates of de novo mutation in the sperm of fathers when they age, but there might be also other contributing factors. But these two combined do not explain a large proportion of the pool of autism. No more than probably 2 or 3 or 4%. So if you could block fathers to have children after age 40, and we could never use alkyl valproic again during pregnancy, maybe we would save, there would be 2, 3 or 4% less, fewer children with autism. This is a measure we call proportion of attributable risk. So, I mean, these are, I think, real associations which indicate a causal pathway, but they do not apply to a high number of individuals with autism. So the question of environmental risk in autism remains open. We need to study better with approaches that I discussed with epidemiological tools. We need also very large samples and now we have the tools of the genetics, which we can actually measure genetics in the mothers. And there are a number of cohorts like ALSPAC, MOBA in Norway, where the investigators have longitudinal data from the children, from pregnancy to childhood to adulthood now, and they have data on the genetic profiles of the mother during pregnancy exposure. But we need huge numbers of participants to achieve something with this course. So I think I'm done. Yeah, you can read that if you want, but I think the idea is what I said. Yeah? One study, never enough. Observational studies in epidemiology is just, even though they are complicated statistically, at the end it's a correlation, and correlation is not causation. And in most situations, there are confounding factors in any study, which are either measured, but we don't control them well because they're not well measured, and there are the unconfounded factors that we don't even know about, or they are not measured, and there are the genetic shared factors, which are also need to be controlled, especially because, as you saw at the beginning, autism has a high genetic determination. So if, that's a personal view, if an environmental factor is going to play a role in the etiology of autism of some, maybe, or a subgroup of families, it's going to be probably in conjunction with some kind of genetic vulnerability, like a gene-environment interactions or something of that kind. And we are not really yet ready to identify it. So but we need to continue. And I think it's done.
Abarca a todos. Entonces, empezamos con cosas muy sencillas y les voy a ir complicando la vida un poco más, ya que cuando hablamos de orientación sexual, identidad de género, estamos hablando de elementos que tienen que ver con ciencias de la complejidad. Y además, si lo mezclamos con las neurodiversidades, o como yo lo llamo las neurodivergencias, se vuelve todavía más complejo. Entonces espero que disfruten y no me pregunten cosas, ¿va? Porque llevamos aquí 7 años. Entonces, la identidad sexual de los sujetos se basa en 3 componentes. La identidad de género, que es la manera en cómo yo me veo a mí mismo como hombre, como mujer, como neutro o como ambiguo, y solamente me veo a mí mismo. La orientación sexual, que tiene que ver con la manera en cómo yo me vinculo afectiva, intelectual y sexualmente. Y esto es muy importante, chicos, porque si no tienes afectivo, intelectual y sexual, no te puedes definir como heterosexual, homosexual, bisexual, pansexual, asexual u otra cosa. Y el rol de género, que es la parte más sociocultural, más humana, que es lo que hace una persona para decirle a los demás que es hombre, mujer, neutro o ambiguo. Y esto cambia con el tiempo y es en un lugar y en un momento determinado. Entonces tenemos elementos aquí socioculturales, biológicos e individuales. Estos tres elementos nos hacen entendernos en nuestra propia orientación, nuestra propia identidad y la manera en cómo lo expresamos en un momento y en un periodo de tiempo. Entonces, nuestra identidad sexual se basa en muchos elementos. La mayor parte de nosotros lo vemos de manera binarista, pero es más complejo que eso. Con respecto al sexo biológico, ustedes saben, XX, XY, va más allá. Tenemos estados intersexuales, una serie de alteraciones cromosómicas o genéticas que nos hacen mucho más complejos. Así que si su tía panista les dice que solo hay hombres y hembras, no, mi amor. Hay machos y hembras y otras cosas. Con respecto al género, también lo vemos como masculino y femenino, puede ser cis o trans. Pero también tenemos estados no binarios mucho más complejos, en donde existen sujetos a género, bigénero, trigénero o género fluido. Si lo vemos con respecto a la orientación sexual, también es más allá del binarismo. Hay heterosexuales, homosexuales, asexuales, bisexuales, pansexuales o demisexuales. Y además, para complicarles más la vida, las conductas sexuales en los seres humanos son muy distintas y no tienen que ver ni con la identidad ni con la orientación. Es decir, las cochinadas que a ustedes les gustan y que todos hacemos van más allá de la manera en cómo nos identificamos. ¿Va? Entonces hay mucha cosa rara. El género entonces va mucho más allá de la anatomía de los sujetos. Tiene que ver con una expresión. La identidad de género en los seres humanos aparece alrededor de los 18 meses a los 3 años. Los niños saben que son niños o niñas. Y esta expresión es muy importante porque lo vamos viendo y lo vamos descubriendo. Tenemos entonces que entender que es una minoría sexual. Las minorías sexuales son aquellos sujetos que por orientación sexual, identidad de género o prácticas sexuales consensuadas difieren de la población general. Y esta banda representa alrededor del 15% de la población general. Entonces en México tenemos aproximadamente entre 13 y 18 millones de personas que pertenecen a la diversidad sexual. Solamente para Ciudad de México, entre 850,000 y 1.2 millones de personas. En Latinoamérica tendríamos casi 100 millones de personas, aquí sus tías lenchas, su tío Jotito y demás. La neurodiversidad es otro concepto más amplio, en donde además convergen, ¿va? Entonces, la idea de este elemento es pues reconocer que existe, entender que no hay maneras correctas de pensar y sobre todo son grupos por características de comportamiento neurológicas o biológicas, son diferentes a los neurotípicos. La prevalencia aquí va del 15 al 20%. Esto quiere decir que en México podríamos tener entre 19 y 26 millones de personas y solo para la Ciudad de México entre 1.2 y 1.7 millones de sujetos que pertenecen a las neurodiversidades. Me voy a enfocar mucho más hoy en trastornos del espectro autista y sexualidad porque es necesario hablar de esto. Y además es un chingo de neurodivergencias, entonces no puedo con todo. ¿Por qué? Porque las neurominorías, como las podemos conocer desde salud pública, tienen elementos que van desde la discalculia, dislexia, déficit de atención, síndrome de Tourette, otros aspectos dentro de los trastornos del espectro autista. Hay características sí muy peculiares como aislamiento social, elección, son incomprendidos y demás, pero también son sujetos que tienen habilidades importantísimas en hiperfoco, atención, creatividad y memoria, mucho más superiores al resto de la población general. Entonces, a menor discapacidad, estos sujetos se pueden enfocar y pueden tener y presentar talentos extraordinarios. Entonces, dentro del déficit de atención, por ejemplo, pues tenemos personas que pueden innovar, tener hiperfoco y demás. Sabemos que los síntomas clínicos son complicados. Dentro del autismo son personas que tienen atención al detalle, son lógicos, con mayor retención y capacidad para innovar. Para la dislexia, personas que pueden ser mucho más creativas, tener mayor comunicación verbal, diseño y un aumento en el panorama. Los pacientes con trastorno obsesivo compulsivo van a tener mayor atención al detalle, atención y liderazgo por pinches cuadrados. Pero nos vamos a enfocar en los trastornos del espectro autista. Hay características específicas, mayor proporción de nombres, ustedes ya son expertos en esto. La prevalencia de la orientación no heterosexual va aquí entre el 70 al 50% en comparación de las personas que no lo son. Y esto es algo bien interesante porque hay una concurrencia aquí entre variabilidades con respecto a orientación sexual que es diferente a la población general. Y esto está muy padre porque son dentro de los grupos que tienen mayor variabilidad en orientaciones, después de las mujeres trans. En las mujeres trans, alrededor del 70% son bisexuales, asexuales, pansexuales, demisexuales y demás. Con las personas en trastornos del espectro autista, esto también es una mayor proporción a diferencia de las personas neurotípicas. Entonces, tienen una orientación diferente a lo hetero. Y esto es como fantástico, porque hay diversidad dentro de la diversidad. Entonces, de lo que sabemos, 22% de las mujeres pues declararon ser bisexuales, y además, dentro de las mujeres con trastornos del espectro autista, ellas presentan todavía una mayor variabilidad. Y esto es muy interesante porque 6% se pueden reconocer como homosexuales, es decir, les gusta la comadre, y 16% pues indicó que no se sentía atraídos ni por hombres ni como mujeres. No necesariamente los hace asexuales, simplemente puede ser un componente interesante de sus características. 80% de los hombres con trastornos del espectro autista sí reportaron ser heterosexuales, 5% homosexuales y 8% bisexuales. Pero esto es mucho mayor a la población neurotípica. Y es algo entonces que tenemos que saber y preguntar. En todos los grupos de pacientes quienes seamos clínicos es importante preguntar identidad de género, orientación sexual y prácticas sexuales. Porque esto nos hace más incluyentes, nos hace enfocarnos también en otras necesidades de los sujetos adolescentes y adultos, y sobre todo nos hace innovar en conceptos en donde tenemos que llevar también educación sexual a poblaciones que antes no la tenían. Nuestro trabajo como expertos en salud es generar servicios y educación a grupos que antes no lo tenían. Y esto es fundamental para todos y generar un cambio positivo. Entonces, aquí hay como una serie de investigación donde vieron individuos que tenían una discapacidad y demás, y encontraron también que la mayor parte mostraron interés justamente hacia el otro género. Aquí May, en este estudio, pues no observaron diferencias entre la orientación sexual entre los sujetos neurotípicos y los que no, pero la mayor parte de los estudios nos revela que probablemente las mujeres con TEA tengan mayor variabilidad en orientación y sean bisexuales, heterosexuales y demás cosas raras. Entonces, lo que sabemos es que hay una mayor cantidad de variaciones específicas entre las personas con trastornos del espectro autista. La mayoría de los adolescentes también aquí tienen ideas románticas. ¿Y esto qué quiere decir? Quieren tener pareja, quieren entrarle a la comadre, al compadre, a los dos. Y esto es importante para saber, ¿va? Expresan entonces frustración, confusión, por justamente la falta de confianza para poder establecer relaciones. Y es una situación que a los chicos con TEA puede generarles una mayor frustración y problemas en la socialización, otro problema más en la socialización. Y las dificultades son pues el rechazo, la ansiedad y la falta. La mayoría de los adolescentes también reportan algunas experiencias sexuales o masturbación. es algo que disfrutan y es algo que está pasando en estos grupos. Entonces, el problema es que los padres subestiman estas necesidades. El lenguaje de algunos pediatras es que son unos angelitos, igual las madres y demás, entendiendo entonces que hay como una mayor discapacidad sexual. Y estos chicos requieren, necesitan estímulo sexual como cualquier otro sujeto. El placer nos ayuda también a un mayor desarrollo. La actividad sexual, besarnos, fajarnos, nos mejora la calidad de vida. Y quien no se ha dado un beso o un buen cogidón o un ajuste de matriz, nos podría decir que ayuda y mejora el ánimo. Entonces, también estos chicos presentan una serie de elementos como ¿cómo imagino que sea mi pareja ideal? Y ustedes saben que mientras más viejos somos y demás, a veces el único elemento es como que respire. Pero bueno, son adolescentes, les preguntaron cosas y demás les quieren que su pareja... Ingenuidad estúpida, pero todos somos así. Todos hemos sido ingenuos y todos queremos una pareja que nos quiera, que sea inteligente, romántica y divertida. Para ellos es importante tener pareja y priorizan sobre todo la apariencia física, pero otros valoran más la bondad, como cualquier otro sujeto. Chichis, nalgas, pito, barba es atractivo y nos interesa. Y esto es muy similar a la población neurotípica. Entonces, hay un interés en la sexualidad. 50% de los participantes en estos estudios ya habían tenido relaciones sexuales y las mujeres con TEA reportaron una mayor actividad mucho más temprana. Y estos datos son similares hoy al México actual. En el pasado, mi generación, los millennials, los X y los boomers, empezaban a entrarle al compadre, a la comadre desde los 15 años. Hoy los chicos están teniendo relaciones sexuales de manera más retardada entre los 18 y los 19. Y esto es muy similar a la población general. Entonces, la proporción de personas sexualmente activas en estos grupos es del 70%. 70% ya mantienen relaciones sexuales. Y esto es importante de conocer porque no son angelitos, son seres humanos como nosotros. Tenemos que dejar justamente de hacer estas categorizaciones y entender que hay elementos importantes, servicios, atenciones y procedimientos que nosotros como expertos en salud mental tenemos que preguntar para mejorar la calidad de vida de nuestros sujetos. Y la edad promedio es entre 18 y 19 años como cualquier otro centennial. Es un poco más tarde que nosotros, pero muy cercano a la población neurotípica. Entonces, los sujetos describen igual que nosotros las actividades sexuales como ricas, placenteras, lo cual está bien, pero podemos observar variaciones distintas por la característica de este grupo humano, que son pues, los problemas en el procesamiento sensorial. No siempre van a entender qué están sintiendo. Intereses obsesivos y dificultades en las habilidades sociales y la comunicación, porque para coger, para fajar, para seducir, se requiere un elemento importante que llamamos inteligencia sexual. La inteligencia sexual es la capacidad que los seres humanos tienen para dar y recibir placer, saber qué hacer, y esto es un factor importante. Entonces, la inteligencia sexual requiere elementos de socialización, entender lenguaje verbal y no verbal para poder comunicar y transmitir lo que queremos hacer. Y entonces aquí puede haber una serie de dificultades específicas que pueden ir aprendiendo conforme nosotros socialicemos. Pero tenemos un beneficio, chicos. La mayor parte de los chicos con TEA latinos tienen un hiperestímulo en la socialización, y si no, quien sea neurotípico, sabemos que desde los 3 años vamos a bautizos, bodas, bautizos, piñatas, 15 años, velorios, muertes, bodas y demás. Y entonces un chico con TEA latino va a ser mucho más sociable que el japonés y el alemán promedio. Ese es un beneficio. Nuestra cultura, dentro de todos los problemas que pueda tener, favorece la socialización sí o sí. Por lo tanto, a estas personas, los acercamientos sexuales va a hacer que sea un poco más fácil que en otras áreas del planeta. Entonces, tenemos que valorar las funciones sexuales, las dificultades y demás. Los problemas, pues, tienen que ver también con la excitación, la hipersexualidad o los comportamientos normativos que en teoría tenemos que hacer para fajar, besar o tener relaciones sexuales. Y esto puede ser un problema, pero si los clínicos empezamos a explicar esto de una manera mucho más fácil, podemos cambiar la vida de los sujetos y que disfruten, porque no son seres asexuales la mayoría. La mayoría tiene un interés específico en convivir y pasar la bomba. Entonces, las dificultades aquí con estas personas tienen que ver con la expresión del comportamiento sexual. La masturbación, como en todos nosotros, es muy común y necesaria y deliciosa. Recuerden, los hombres requerimos 21 eyaculaciones al mes para evitar cáncer de próstata. Las mujeres también requieren más de 20 orgasmos para mantener el sistema inmune útil. Entonces, esto es necesario y lo hacen todos, seas o no neurodivergente o neurotípico. Hay estudios que muestran interés en las relaciones sexuales, como ya lo mencioné antes. Mayores tasas de relaciones románticas mientras más grande eres, pero porque tienes mayor estímulo social es mucho más fácil entonces tener un interés en tener una relación. Hay aquí, ojo aquí, comportamientos específicos con una serie de elementos con las filias, ¿va? Como exhibicionismo, fantasías pedófilas. No es que sean pedófilos, es una fantasía sexual. Y los expertos en sexualidad, mientras el sujeto no cometa un acto, se puede tratar en psicoterapia y entenderlo, y puede ser una idea pseudo-obsesiva. Entonces se tiene que investigar perfectamente bien. Fetichismo, sadomasoquismo y otras parafilias, pero el fetichismo y el sadomasoquismo, como sabemos desde 2016, no son conductas sexuales desviantes. Son conductas sexuales que todo el mundo quiere, siempre y cuando sean consensuadas. Es decir, si tu fantasía es que te amarren como puerco y tu pareja y tú ya lo hablaron, disfrútalo y déjate ir. ¿Me entienden? Y es muy interesante porque el 40% de las mujeres quiere ser amarrada, así como tal y cantar fuego cruzado. Eso dependerá de ustedes. También las conductas sexuales son más deviantes en algunos casos por comportamientos repetitivos y que podrían ser considerados inapropiados. Pero recuerden, a mayor socialización estas conductas se reducen y el sujeto puede entender entonces qué es lo que le gusta y a qué le quiere entrar. Entonces, lamentablemente, al ser una población que es estigmatizada, una población minoritaria, y toda población minoritaria va a presentar mayor riesgo a infecciones de transmisión sexual. Les recuerdo que los pediatras, los psicólogos, los psiquiatras, si los ven como angelitos asexuados, no les van a dar la suficiente educación sexual para hacer tratamientos específicos a una población que así lo requiere. Entonces, nosotros tenemos que entender que hay un mayor riesgo a presentar infecciones de transmisión sexual, y como padres, como educadores, como maestros, como profesionales de la salud, siempre tenemos que favorecer el uso de lubricante, condón, PrEP o PEP, para evitar la transmisión de VIH, hepatitis B, sífilis y gonorrea, que son las más frecuentes. Entonces, es importante que entiendan que las infecciones de transmisión sexual son casi 3.5 veces más que en la población general. Y este es un factor de riesgo justamente por la mala educación sexual y por la estigmatización que hay en los grupos de la neurodiversidad. Entonces, hay un mayor riesgo a abuso y violencia sexual también en estos grupos. ¿Y esto es por qué? Porque no entender las intenciones de la otra persona, no entender cómo es la socialización con un abusador, nos pone en un riesgo mayor que la población general. Y es algo que tenemos que conocer en estos grupos de neurodiversidad, de hasta 2 a 3 veces más que en la población general. Y esto es entonces un factor que también tenemos que considerar, porque una situación de trauma en una persona neurodivergente puede agravarse tremendamente y tener entonces fallas en el diagnóstico y hacer que se confunda con una persona con TLP. Entonces, ojo aquí. Entonces, hay una mayor vulnerabilidad por dificultades en la comunicación. Las mujeres tienen mayor riesgo a sufrir violencia y abuso sexual. La comunicación limitada también pues, favorece entonces que no se entienda bien estos conceptos y pues hay muchos problemas específicos. Ahora, aquí hay como un elemento también de coocurrencia. Dentro de la población del espectro autista o neurodivergente, encontramos también mayor prevalencia de personas trans que presentan en el pasado, o dependiendo del DSM-5-TR, pues, disforia de género. Nosotros lo llamaríamos hoy condición transgénero, porque es una condición normal dentro del género humano, pero aquí sucede mucho más. CIE 11 ya lo considera como una incongruencia de género. Aquí no hay problemas de ningún trastorno mental específico asociado. Es necesario que hagamos una mayor investigación en estos temas, porque tanto la concurrencia como las necesidades específicas en los grupos minoritarios pues nos ayudan a generar información válida y capaz. Entonces, la mayor cantidad o una mayor proporción de personas con trastornos del espectro autista presentan variaciones en el género que van de 5.2 a 11.1. Pero esto es de 5 a 11 veces más que la población general. Y esto es bien interesante porque la población trans en México son alrededor de 1.3 millones de personas, de niños adultos. Es el 1% de la población y como ven aquí es un chingo más. No sabemos bien por qué, pero hay como la aparición como de ciertos genes que estamos estudiando. Estamos en milimegenes, tuve que investigar los pinches genes. Entonces hay una superposición entre los trastornos del espectro autista y las cuestiones de género, especialmente en mujeres. Esto va, y es mucho mayor también en los niños, pero generalmente las conductas género-variantes son mucho más frecuentes en los niños. Y hay como rasgos específicos y demás, y hay una relación entonces significativa en diversos estudios genéticos, sociales y de variaciones en las conductas sexuales. Entonces, más rasgos de disforia en los individuos y puede ser casi hasta el 8%. ¿Entienden eso? Esto es 8 veces más que la población general. Es significativamente mayor y lo interesante aquí es que además no todas las personas se identifican como trans, sino se puede identificar como personas no binarias o género fluidos. Y entonces, si eso es difícil para mí entender una persona trans, las identidades no binarias que son agénero, bigénero, trigénero, queer o fluido, pues me pueden a mí reiniciar. Como clínico, si no estamos expuestos a entender estas variantes de género humanos, podemos justamente también generar procesos inadecuados de atención. Son sujetos además que podría costarles un poco explicar sus necesidades o explicar su propia vivencia. Por eso tenemos que tener una mayor especialización en cuestiones de género para poder abordarlo y preguntar claramente, oye, ¿cuántos géneros hay dentro de ti? ¿Eres hombre, mujer, neutro, ambiguo? Neutro femenino, neutro masculino, te mueves entre la masculinidad y la feminidad, y esto nos ayuda a que los individuos también puedan abrirse, comentarte cosas y entonces tener intervenciones específicas a un grupo que antes jamás se le había preguntado algo así. O sea, hay que hacer las cosas bien para que salga chingón. Entonces, sabemos que las mujeres con TEA tienen mayores variabilidades en el género. Resulta que aquí la testosterona es un cruce que nos ayuda como a entender un poco más los trastornos del espectro autista y las variaciones en el género. Según algunos biólogos evolucionistas, la testosterona y pues tener algunos genes neandertal que el 3% de nosotros heredamos tiene que ver con la ocurrencia de los fenómenos asociados a la neurodivergencia. ¿Cuál es su proceso femenino? Ya lo dije, mi amor, bien. Entonces, la testosterona hace que los cerebros se vuelvan cada vez más concretos, rígidos y demás. Los estrógenos generan otro proceso y demás. Yo sí soy ferviente de que existen cerebros en general masculinos y femeninos en la mayor parte de la población. No hay una diferencia entre estos dos cerebros, llegamos a los mismos resultados. Solo el proceso es distinto. Y la testosterona hace que seamos más concretos, menos repetitivos y menos afectivos. Todo el mundo le ha preguntado a su güey, ¿cómo te fue? Que se bien, y tú, hijo de tu puta madre, quiero que me contestes un poco más, me gustaría conectar contigo. Entienden eso y lo saben bien porque lo han vivido. Entonces, también evidentemente las alteraciones en la socialización y demás hacen que seamos distintos, pero recuerden, el beneficio que tenemos nosotros es ser latinoamericanos, anilianos, guadalupanos. Aquí los hombres bailan y es bien visto que bailen, de hecho es un elemento asociado a masculinidad y eso hace que conectemos. Aquí los hombres pueden platicar un poco más, al menos entre ellos, esto lo llamamos homofilia. Probablemente cuando se tome la foto con ustedes va a salir así el güey, y cuando está con sus cuates, lo cual tiene que ver con cuestiones de género, pero también elementos no necesariamente tan negativos. Las personas en Latinoamérica estamos orientadas a pinche socializar todo el tiempo, en todo momento, en todo lugar, como la ñora que está platicando en las escaleras de metro cuando tienes prisa. Eso es un fenómeno social. Y la testosterona lo puede afectar, pero lo contrarrestamos siendo latinonas feas. Entonces, hay elementos aquí específicos también que tienen que ver con inflexibilidad cognitiva, dificultades en la comunicación, dificultades sociales que construyen justamente elementos que pueden incrementar la disforia de género. Estos estudios genéticos se hicieron en países millonarios y además aquí era cuando podían amarrar los perros con longaniza y no se la comían. Buscaron gemelos idénticos, buscando polimorfismos, y son los primeros estudios así que nos volaron la cabeza porque entonces encontramos 3 genes candidatos en su momento, que tu receptor de andrógenos, el estrógenos y la aromatasa. Esto en su momento fue algo innovador y que cambió, pero para más o menos 2019 encontramos 19 genes con 21 variantes, que ya no nada más tenía que ver con los receptores de estrógenos y testosterona y aromatasa, sino que tenían que ver con elementos de desarrollo de la corteza medial prefrontal, socialización y demás, lo cual nos puede llevar a que la identidad transgénero es una condición biológica necesaria en los seres humanos y que tiene concurrencia con las personas neurodivergentes. Pero también entonces tengo que hablar que si eres de la diversidad sexual y además perteneces al 1% de personas con trastorno del espectro autista, pues se va a poner feo, lamentablemente, y esto es por inferioridad legal, inferioridad educativa, violencia, discriminación y demás. México es un país que está compuesto por minorías. No existe una mayoría étnica aquí. No es lo mismo ser mestizo en Ciudad de México que ser mestizo en Monterrey